she sees too.
Huh.
Chat is rolling okay, but I don't see your script. I don't see your live stream.
Okay, do a refresh because I see it.
Hmm.
I'm looking at it right now. Live.
Okay, there it is.
Yeah, make sure you, Izabela, just do a refresh and it'll be there.
Very good. I got it now. Thank you.
No worries. No worries. The other night we had a real technical glitch with the telescope doing some odd things. You know what it turned out to be? I wrote a message in the description which you can read, but the the software that I use to connect this computer I'm on here in Connecticut on the East Coast with the computer that's out in the building on the West Coast, actually in Arizona, was actually having an issue. Actually, it was their problem. So it made it happen that it was failing. The connection was being dropped all the time, and you saw how rough it looked. Compare that to this. This is stunning. Well, this is what it should be. Okay, and it's actually going to be even better with Starlink when we get that. So now, if you don't see if you don't see our stream, then refresh your screen. Just refresh the browser, and it'll be there. I don't know why. Sometimes it does that, but Daryl didn't see it. Izabela didn't see it. So if you don't see it out there, make sure that you refresh your screen.
Yeah, I see it now.
Okay. I just wrote there. There we go. Okay. Now, the one thing that I'm going to do is I'm going to remove this purple halo around this star. Okay, the purple color is due to the filter we're using, but because of the filter, we can see all this extremely delicate information in this nebula. Look at this. It's just getting better and better, Daryl.
Yeah.
It's just getting better and better.
That's going to process really nice, I bet.
Oh, I think so. I just think it will, But I'm going to get rid of the halo, and I've been threatening to teach Izabela how to do that. I know that for those of you that may not know, Izabela's been doing all the table of contents for our videos. She's taken it upon herself to do that, and she does a really, really good job. And I want to thank her publicly for that. Izabela, thank you. Thank you very much from the bottom of my heart. You are doing such a good job. And she also takes our images and processes them. Izabela, put up the link to your page, will you? So people can see that. I'd love to have them go to that at some point and check out what you do and how you process the images. And it's not just ours. You process other people's images as well. And I love what you do. So please put your link up there, okay?
Oh, she shared a really pretty shot of M42 and Orion she did the other day. Shared that with me. It was really nice.
She does a great job. We actually had her on the show here with us. She was live with us from Sofia, Bulgaria. Uh-huh. And for her, it's I guess, middle of the morning, or it's in the morning sometime. She's, 9 hours ahead? 9 hours? It's early morning. Something like that. Yeah. Yeah, she says, I haven't uploaded the new stuff, and there's a lot. I bet there is. That's right. Well, we look forward to it. Izabela, put up your link. Please put up your link. I want people to know. Okay, let's see. We've got 40 stacked images here. This is good for this object. Now, for those that are joining us, you've seen this before, I think, but I will share with you what's going on. When I save the stack, the sandwich of images, then you see it across the top of the screen there. It's a FITS format, F-I-T-S. You can get some free readers to see it, but you're not stuck. If you don't want to look at a FITS file or get involved, if you don't know what the files are or whatever, then you can just wait for this next one, because what I do is I save this stack, which you can read with a FITS viewer. They're free. Or I save this image just like you see it. And then this image is available just like you see it here. And right now, because I saved it, I'm saving it to the local machine in the observatory building. But then the observatory building takes those images and ships them right up to the cloud and to our private server that I have given all of you access to. And if someone would be so kind as to put that link in to the private server, that'd be wonderful. I appreciate that. All right, well, thank you. Okay, so this is wonderful. So we're going to clear this now because we've seen it. We will process it later. And now let me show you what it looks like just if you looked at it in sort of a little telescope. Okay, so this is just about what it would look like. All right, let me show you. Okay. So, not quite that. But it would look kind of like this. I'll bring it up now. Okay, if you looked at it in a little telescope or just a reasonable telescope, you might see it with a little bit of a little nebulosity, little like that. This is about how you'd see it. Okay, just a little bit of nebulous detail and a little bit of a satellite going through. Okay, so that's what you'd see with the telescope, not even knowing that there's a whole dark nebula right here that you're not seeing. How about that observatory, huh? I hear it's good. Just kidding. So yeah, I think that's pretty cool. Let me change my white balance a little bit there. That's good. Okay, I've got my auto temperature focus system running too, so we actually have the temperature making changes to our focus because as instruments cool down, the focus changes. Hey there, Daisy and Zoe. How are you? It's nice to see you. Roni Hassan is here. How are you? Nice to see you as well. Okay, so let's go check out some other objects.
Can we zoom out on that image first? Take in the whole thing one more time?
Yes, we can. Yeah, let's do that. This will just show you the whole area. So there's the whole area.
I don't see the clouds anymore. The dark nebulosity.
Oh, that's because this is back to a 1 second exposure.
Oh, okay.
Yeah, I cleared out of it. Sorry. I'm sorry.
All right. No worries. No worries.
Okay.
Carry on.
No worries. Okay. So one thing I'm going to do is I'm going to check the temperature in the building right now. Temperature was 61 just a moment ago. Let's go check. It's still... Okay, now it's 57.3. Okay. And the focus has changed. It's gone down. Okay, so it's actually... As the temperature goes down, the focus changes. And so it's actually changed. All right. So here we are in this area. And we can try looking at the Chrystal Ball Nebula right next door. But I have a feeling it's just going to be a little tiny, planetary nebula.
Yeah.
It's not going to be much. It's not going to be like the... whatchamacallit, the dumbbell. All right, let me get back out where I can see the telescope. Boom, there we are. Now you see the telescope right here. And don't do that. I want to do this. Yeah, welcome to the world of satellites. I mean, I also made a tweak to the stacking algorithm here. So over time, when the satellite streak goes through, as we stack more and more, that satellite trail goes away. It's auto-deleted over time. You just need to get more time. So that's what we're going to do from now on. All right, so let's go back to this again. And why don't we go with a crystal ball? Let's just see. All right, well, first, before I do that, I'm going to tweak the telescope so I can get my display working, which you see right here. All right, and now I come back in here to the Planetarium program that is connected to the telescope, and I'm telling it to go. So right now, it's heading. You can look at the telescope over my head. You can see what it's doing. Okay, it's not going to move far because it's going to an area right near the past object we were just in. Okay. So, if anybody has issues with sound, well, let me know. Thank you, Izabela, for putting up that directory. Thank you very much. That's the address to our server, so you can see what's going on. And you're also going to find the Pleiades up there, a little bonus object. I threw those in there. I did those a little while earlier, just to do a time. It was like a 40-second exposure stacked of the Pleiades. Okay, so let's see what we got. Well, you can't miss it. There it is, right there. There it is. Yeah. But we had discovered that with this telescope and with this setup, we can zoom in really far without a tremendous loss of integrity to the image. But look at that, Darryl. That's pretty right there, huh?
Uh-huh.
Wow, that's really pretty.
Stack first, or will it go right in?
No, I'm gonna stack.
Okay.
I'm gonna stack a few. So I'm gonna move over, center it up.
Is this still just a 1 second exposure?
This is, yes.
Okay.
Yeah, if you look, see down here, there's no line, there's no additional line. You'll see live stack come up.
Right.
Okay, so like if I say, if I make this like a, let's make this a 10-second exposure just for fun. Okay, and then I get rid of this hyper processing. And then if I click live stack, you're going to see a new line down here, live stack. Okay, now we're stacking. All right, and if I come out of it, it just goes away. But it's still there. You can still see live stack. Okay, and look at that. Holy cow. Let me bring up the live stack again and do an instant process on it to bring it out a little more. Wow. This is going to be pretty, Darryl. Look at that.
Yeah, it is. It's already
Holy
pretty.
cow. Yeah, I'm going to do a color correction.
Zoom in some.
Yeah, I'm going to do a color correction. Okay, there's a color correction. So this is the accurate color, and the color is being generated by the element oxygen. Oxygen in stars of this type is generated in the cores, because the stars are processing hydrogen into helium, helium into carbon, and nitrogen and oxygen. So the star has to be a little bit more massive than the sun in order to make oxygen. Okay, and when we look at this star had to be more than say two solar masses, and it actually makes this beautiful, as it threw off the outer envelope, what you're getting, wow, look at that. What we're getting in addition is we're getting this oxygen, all right, and this oxygen was made in the core. Some of it was inside the star's envelope when it was made, and it never changed, okay, but there's a process, okay. Oxygen is made outside the central core. It's in the outer area in a shell. All right, and they're made the shell. It's called shell burning, and you have helium shells, you have nitrogen, oxygen shells. Okay, with an outermost shell still being the hydrogen, and the oxygen gets dredged up from the interior and brought out into the envelope. But then that envelope is drifted away from the star as the star bloats and does this pulsation thing as it gets older. All right, and look at that. This. We can see this is actually really great. This is gorgeous.
It is.
My gosh.
Do you remember the name of this
zoom in
object?
more. I sure do. This is the Chrystal Ball Nebula, I believe. Chrystal Ball Nebula. Yep.
Okay.
Indeed.
15, 14.
Yep. Yeah.
That's very nice.
So there it is. And it does, and I'm going to actually go to 100% now. This 100% is not like zooming. This is right here at this point right there. This is the actual native size of the sensor. We're now looking at it at the size that it wants to be seen at. But because it's such a big sensor, I have to shrink down the image to fit on the screen. That's why you see it. But this is how it normally looks. So we could go from, as I was saying, so you can see this right here right? This is what it normally looks like. Okay, that's the whole center. That's 4 full moons across and 3 full moons up. Okay, and so we can go from that to 100% and look at it at the native size, native resolution. Look at that. Wow, it's getting better and better. Man, this is just something else. And I even see an outer shell here.
Yes.
Beginning to show up. So an outer shell out there, that's pretty cool.
There's quite a bit of detail on that.
I see, there is. So I'm actually going to change our dark level a little bit. I'm going to bring the dark level in just a bit. Darken up the background. Yeah.
Often seems to be the case when we look at planetary nebulas anymore. I remember when we looked at the one in, what was that, M46 the other night?
And we're going to see that again tonight, I think. Yeah.
Okay, we could actually see a fair bit of detail on that, which I don't think we'd ever seen before.
Correct.
It's impressive.
I believe it's true. Yeah. Yeah, this is just beautiful. Go away. That's something. So that's a planetary nebula. What is that? Well, obviously it has the name because of the fact that the planetary appearance of it in a small telescope gives it its name. Okay, but the reason that it's a shape that it is and the color that it is because this is the end state of a star. All right. When a star dies, we get a planetary nebula. And this particular planetary nebula, like the Dumbbell Nebula, like the Ring Nebula, like M76, which is another planetary nebula, and like so many other planetary nebula, the Helix, okay, they all. Izabela says Calabash Nebula. Well, that's another nebula. So when we look at these. When we look at these things, okay, we're looking at, besides looking back in time at them, we're actually looking at these objects at a particular stage in their evolution. They're expanding. Those shells are expanding around the star. Okay, those shells are expanding out. That green is expanding out. Okay, the stuff on the outside isn't necessarily the first stuff that was emitted. Okay, because what happens sometimes is the star has pulses. Sometimes stuff is gently and lazily floating away from the star, but then there's an inner pulse that goes fast and overtakes it and passes it. So it's not clear when such things happen. This is part of the reason why it makes it so hard to tell the distance to planetary nebulae. Okay? So you follow what I'm saying? Okay, it does this gentle drifting away, but then another pulse inside can make a real powerful pulse that goes out faster, and it will overtake the previously emitted stuff. So we don't know what's happened here, but look at this. This is gorgeous. I'm just like, we pass over things like this because they're quote unquote so small. But look at, we're actually capturing quite a bit of fair amount of detail here.
Oh yeah.
Wow. And what's interesting is you notice it has like this appearance of like a vertical line here. Okay, this nebula also has a horizontal component to it. You see that? So it's actually got an odd geometry to the clouds. Now that could just be the way the clouds are laid out. Some could be here, some could be here, some could be over here. Because again, it's a 3D object that's projected on a flat plane as far as we can see. But there's enough differences in there that show me that this nebula expanding out into the interstellar medium was probably in an area where there was other matter, okay, other interstellar dust and other things. And so it's probably why it looks so disheveled, why it doesn't have an evenness or uniformity. It has a remarkable spherosity to it. It looks like it's a relatively spherical shape, but it could be due to pulsations on the star that cause a lack of material here versus here. It could be that this is somewhat bipolar, which is another category of planetary nebulae, bipolar nebulae. The Dumbbell Nebula is bipolar. It has very little stuff on the sides, relative to these big, giant hourglass things at the top and bottom, that hourglass shape. So bipolar nebulae are another possibility, and there might be some of that shared here. If the star was a rapid rotator, for instance, that could have been part of the reason. But this is really nice. We've actually stacked almost 50 objects here. So we're gonna.
What's your exposure time?
The exposure time is 20 seconds. No, it's not. What did I say? No, I didn't say that. I think it was less than that.
10 seconds?
Yeah, 10 seconds. Yeah. So it's 10-second exposures. So what I can do is I'm going to save this. Okay, I'm going to pause it first. I'm going to do something else, which is just for fun. Let's see if there's any more out there. Let's see if we can bring out detail in that outer ring. I'll save it like this and save the object exactly as you see it here. Okay, now what I'm going to do is I'm going to go here. Instead of 10 seconds, I'm going to do 30 seconds. And see if there's additional material. Now, the inside of this is going to get really bright and probably overexposed. But I want to see what we get. So here we go. So I'm going to go into the stack. And I'll clear it. Why not? And now the 30-second shot's going to come in. And we're still in the Chrystal Ball Nebula. So this should be interesting to see.
The central star in the Chrystal Ball Nebula is actually a double star. The bright visible component is a giant star. It's an A03 star. And the nebula generating companion is now a hot subluminous O-type star. Blah, blah, blah. William Herschel discovered it in 1790. He described it as a most singular phenomenon, forcing him to rethink his ideas on the construction of the heavens.
And that explains why we have these dark objects in here. Because it's a binary star. Wait a minute. It is a binary. Look. I see 2 components. Is that not real? I should zoom in more. Let's go to 200% and see if I'm seeing things. No, I'm not. Look. There's a star here.
Yep.
And a star here. So this has to be the one generating the nebula. And this has to be the other component. Now what happens is, it could be that one of these stars was, in fact, most likely this star here, the lesser bright one, was bleeding material onto this star. And then that star decided to, went into its red giant phase, started expelling material. This envelope is all tattered like this because there's 2 stars orbiting each other here. I can see we got a little bit of a focus issue here as well. So I'm going to go check that and make sure that we fix that. So I'm going to do that right now. So we're going to go back to just a 1-second display for now. And kick off the live stack. I didn't see any more data. Okay, let's see what we get. All right. Not there. Maybe. Let's do this. Okay. We can get out of 200% and come back to 100. Okay. All right, let me just do a focus adjustment here. Let me turn this off here. See what we got. It's 56 degrees. I have an Excel spreadsheet with formulas in it that I made up to help me with this, to figure this out. Whoa, big satellite going through there, huh? It's pretty close. Let's see what that does. Okay. We're looking almost straight up, so this is good for our focus.
There was a post on
Another satellite.
Reddit recently about Starlinks in particular interfering with observatory views of the skies.
Yeah.
And there have been a couple of articles about it going around recently. One messing with the sky in general, and one in particular that they Starlinks are hindering views of what could be Earth-crossing asteroids. For like
yes,
asteroid watches and stuff.
Yeah, and I heard that, and that's dangerous.
Yeah, I left a comment there about your live streams and how we can hardly do an image anymore without picking up one or more satellites and in a 30-second image, and people got.
Oh, there's
snotty.
one right there.
Yeah, they typical Reddit users, they will heck with you and your imaging. I want my global internet.
Well, and, I want everybody watching us wants our internet to continue, so we have to work on mitigating the trail problem.
Yeah.
And luckily, with this system, trails that are somewhat faint will be gone with 20 stacked images, because that data gets replaced. Because so. This is
the
beautiful.
article, the one article, the post was commenting on had a well-known image of I forget. I think it may have been Orion Nebula, but there was like 100 satellites streaking through the image over the time exposure.
Oh, I saw that.
Yeah.
Yeah, that's pretty bad.
And just people are so narrow-minded. They, us amateur astronomers doing this is one thing, but it's going to affect and harm every professional observatory on the planet. People don't care. I want my internet, damn it.
Well, yeah, I understand.
And plus I say, that's why we built the Webb. That's why we built the Hubble. We'll just go to outer space and do it. Well, still it's going to, it could obviate every professional observatory on the planet, much less every amateur astronomer.
Yeah, that's right.
But what
okay, we're going to another nebula right now. After we center here, and we should possibly fall into it. Let me make sure that the telescope actually knows where it is. Sometimes it doesn't. Okay, well, it thinks it knows where this one is. So what we have to do is we have to take an exposure here to see. So right now, as what's happening is that the telescope is finding a guide star for us right now. So while it's doing that, this is the telescope control section here. There's the telescope right there. This, of course, is our live view. This right here is our live view of the telescope computer. Over here on the right, you see the camera control section. A lot of parameters to mess with and work with, and they slide out and pop in, go back and forth, back and forth, back and forth. Okay. Hey there, Michael Klages. How are you? He's shooting a monkey head right now. Yeah, we shot that the other night. It's beautiful. Hopefully you got a nice dark sky. Nice to see you here. Thank you for coming. Let's go do we'll try a 25-second exposure just to see what we got here.
Speaking of a nice dark sky, The moon doesn't rise at your location in Arizona until 11:40 p.m. local time tonight.
I know. I'm trying to rush through this. You know, I'm trying to get us to some really cool things so we can get some great data.
Yeah.
You know, that's why I'm looking for the Dark Nebula now. You know, these things now just to check them out. Let's see what we got. Oh, there it is. Look at that. Look at that. You see that thing snaking right through here?
I do.
That's pretty cool. Okay, well, we're going to try it. Yeah, I see that. I'm not, I gotta, and I see, you see like this lighter color here? That's sort of like the typical brownish dust.
I'm starting to see it all over the screen now.
Yeah. But look for the brownish in the dust.
Yeah.
Okay.
Too much LDS
like right here
in
you
the
see
60s,
some.
I'm afraid.
That's funny. LDS.
That's a Star Trek reference, of course.
Yeah.
Star Trek 4 in particular.
Yeah. The voyage home.
Uh-huh.
Mm-hmm. Where are the Navy vessels? What? Where are the Navy vessels? Alameda.
Nuclear vessels.
Nuclear vessels, yes. Okay. You can see this really fleshing out over here, too. Here's the thing. This is exactly what happens when there aren't a whole lot of stars to illuminate a certain area. We only did a 25-second exposure. This needs like a minute, and I'm not going to make you sit through that. So I won't do anything with this one. So we will clear this, pause it and clear it, and move on to another thing. And then I'll do 1 minute, maybe another time, when we have a little more time to do stuff before the Moony comes up. All right.
You've got about 3.5 hours.
Yeah, I'm probably, shush, you know me, I'm probably going to eat that right up. Okay, let's see here. All right, let's drop down here. Okay. Let's do this. Let's see. That's the Pleiades is there. Let's see if we've got. See how many things we got to look for. Jeez, it's like it's endless. Okay, hold on. Let's see if this is something. Oh, this might be pretty. If we can see that. All right, let's go check this out. This is LDN or IC 2087. It says it's interstellar matter, but it's actually dust. You can see the telescope moving to the star now. If you look down here, it says high precision slewing. It's going to pick a bright star and put it into the center of the field. And what star is it? It's Aldebaran. How about that? The Eye of the Bull. And then from Aldebaran, we'll go to this object. And hopefully, we will see it.
Well, that's big.
Okay. Yeah, it's really big. Okay, but you can see some stuff in here. Namely, lack of stars. So I think we're right in the middle of something really pronounced. So let's make this an exposure that's a little bit more like 45 seconds. But we're going to wait for the telescope to catch a guide star. So while it's doing that, I'm going to just... Okay, so it's IC 2087. Okay, so that's what this is. All right. It's IC 2087, and it is Dark Nebula. So we'll check that out in just a minute. Okay. So let's go check it out. Let's see what we can capture. I've never looked at this before. So here we go.
You know, while we're waiting, the Webb arrives at L2 tomorrow.
I know. It's got to do the burn, though, to successfully enter the L2 orbit.
Yeah.
Well, look, it's already passed about 450 failure points, so it has a few more, and then we're done. Okay, let's see what we get. Let's see if we can see something right away. I think I could see something near the center of the screen right away, so let's find out. Oh my. Oh, yes indeed. Look at that.
Huh.
This is huge. Wow. This is going to be really pretty. So we're going to let this develop a while. It's like film developing, you know?
Yeah.
It's like film developing. All right. Let's do this. Let's darken the background a little. Already starting to see some differences in texture come out. This is the stuff from which stars and stellar systems and solar systems like the Earth and its planets and the sun formed. This type of location, this type of dust. I like this little object down here. This reminds me of a Herbig-Haro object.
Uh-huh. Got a little touch of bright nebulosity, brighter.
Right in the middle.
Right in the middle.
Yeah. But oddly, you don't see the star that's causing it. Unless it's one of these stars, which it could be. Or this one. It's probably this star. If it's around the same distance. That's cool. Look at these streaks. I mean, this is really starting to shape up. Let's see what it thinks the color should be here. Get rid of a little, make it a little more dark. That's better. And now let's... Yeah, see, that's too much to me. But I want to see it to see what it thinks is there. Okay. Look at that. You definitely have some wisps over here. We're going to undo that. I'm going to take it back a bit. So we'll take that back a bit. Bring it in. Okay. Right about there. This is really pretty. Look at that. That's something else. Here's an example of again, down here, those little stars right there, you know, these guys, those right there are little, it's a red pair of stars. They might be line of sight, so one might be here, one might be here, but they look like they're next to each other because of the, you know, because we're looking at them this way in perspective. But they also might be right near each other. So that'd be interesting to find out about these stars. Really cool.
Michael,
But as before, you can...
I'm sorry.
What's that? No, go ahead.
Well, Michael said it needed a 5-minute exposure. The telescope is a 10-inch Schmidt-Cassegrain working at f2. It's a hyperstar, and Marc is getting away with very short, like 30-second exposures, and he's stacking them on the fly. That's how we're acquiring the images so fast.
Yeah, so now we could take 5-minute images and do all that, but I also have people watching from all over the world, so I want to make sure that we do something pretty cool in a short amount of time. But he's absolutely right. The longer we go, and there's a limit. There's a practical limit per object. But the longer we go, the better it'll be. Typically, maybe not necessarily every time, but it's definitely something that every astronomer wants to do. Is to try and take long exposures. I used to guide images in the at the prime focus of a very large Schmidt-Cassegrain system in the observatory where I worked, the big observatory, and I did a guiding for like an hour and 45 minutes per exposure. Can you imagine that? Hour and 45 minutes in February. In February. Okay, where the temperature was -4 in the dome. You shiver and you ruin your exposure. So it's like it was a real tough thing to do.
I think the longest I ever guided was 15 minutes.
Yeah.
And that was on film.
Yeah. Well, I had to do the hand guiding because we didn't have a auto guider on that. It was a 24-inch Cassegrain.
Nice.
Yeah, it was a really nice telescope, but it was under relatively light polluted skies. So, to look at something like the Orion Nebula, you could almost see color in some of the areas because enough of that data was coming in to set off the cones in your eye, which need a lot of light to be set off. But boy, it was something. Really pretty. Wow. 8 of these have been stacked. I'll probably go to 10, and then we'll move on, see what we get from there. But this is really pretty. I would like to, while this is stacking, I want to go check. I'll back out of our location here, which is up there. There's Elnath, the Crab Nebula, Auriga, the Flaming Star. That might be pretty tonight, but I'm going to go back to come down here. I'm going to check the height of Orion and where it's sitting right now. Okay. We might be okay to try measure 78 now. Just right around here.
Pete Bodds, your question. I saw an article earlier today. What might they show people first with the web once they get images from it, and to try to capture and keep the public imagination. It was all speculation, but they thought maybe they'd do semi-familiar showcase objects first. And what you might wind up seeing is actually techniques they already do with multi-wavelength astronomy, where they merge the images from the different spectral regions. And so you might see, like Orion M42 in both visible and ultraviolet and infrared images all put together and make up whole new montage images of them that way. That'd be pretty cool to see.
Yeah. Okay, so Pete, by the way, welcome. I forgot to say hi to you. And D. Smith, how you doing? Good to see you too. All right. Hey, it was very cold out there. And then that's right, D. Smith says, you were so cold out there. And it didn't stop you from doing just one more. No, it did not, because I just had to do one more. But now that I'm in a warm facility, controlling a telescope 2,500 miles away that we put out in the desert, I'm at peace with that. I'm at peace with that. So I think that we'll be able to continue to do this. And we're looking at another telescope. I'll tell you, Daryl, about a telescope that I've been looking at and it may come to fruition, it may not. But it's by far one of the best telescopes on the planet.
Yeah.
I just hope it's a little slow optically, but I don't care. This was good for research. Okay, so once again, this is IC 2087. It's a dark nebula complex, but you see this has this one illuminated area in the middle. This is an area that's truly reflecting starlight. Probably not scattering starlight, because it's not really blue. So it might just be reflecting light from a star that might be more distant. And that can happen too, a simple reflection. Okay? And if you notice, if you look around, you can see some faint red. This whole area is filled, suffused with hydrogen gas that is being ionized and forced to glow red. Okay, that's just beautiful. This is a really pretty image.
Right?
I believe we are in Taurus. Let me set up the boundaries so we can see. I moved us. I didn't move us. I've actually... we were up here. I believe we were in Taurus because we went just south of Aldebaran. Okay, I lost sight of it, but it's IC 2087 anyway. That's where we were.
Yeah, I think you were up in Taurus. I was just thinking this has to be part of all the dust clouds in Taurus.
It's really, really, really beautiful. Oh, Michael Klager says, I'll do Pillars of Creation. Yeah, that's the M16 Eagle Nebula. Oh, thank you, Vera Lucia. Thank you so much. That's very kind of you, you know. You guys humble me when you do that, you know. And I just want you to know that was beautiful. Raymond, thank you as well. I forgot to mention that you had sent us a donation. Thank you, brother. I sent Raymond a couple of our crater plates because he was very kind to us with the GoFundMe. I thought that was just incredible. Mm-hmm. Looks a bit purple to you. Where do you see purple? Oh yeah, Andromeda would be an interesting target too. There's a lot that the infrared system on the James Webb could show us, but my target, and to answer your question, Pete, from like 10 minutes ago, my target would actually be TRAPPIST-1. I would like to look at TRAPPIST-1. It has a number of planets, 7 planets, and 3 are potentially in the habitable zone. But what we have to figure out is if those 3 planets actually have atmospheres, and if so, what are they made of? What are they made of? And that is something, that's something that we don't know. And I want to know. Because exoplanets are my specialty in astronomy, so I thought, why not figure this out, right? Okay, we're at 16 stacked here, and soon to be 17. All right, there's 17. We're going to pause this, save it as this astronomical fits file. You see the green bar across the top, confused with the time up there. That should be here, so you can read that. Okay. That's the fits file, and then what we're going to do is save as you see it here, so that you can actually enjoy it just the way it is. I'm going to now, while I'm in here, I'm going to try and increase the dark level just a bit. Draw out contrast between the... There we go. Okay, let's see how that looks. Oh, yeah. Okay, that's going to get saved as it is, too. Just so you have that one as well. Oh, look at that. See what happens when we had the moon? We can actually see some of these dark nebulae because we're using some really good filters to do this. But look at how beautiful that is. Wow.
That is.
The music's perfect. Let's just take another view. Let's take a look. I'm just looking. Hope you don't mind. admiring. Wow. Pete, the James Webb is going to show us a whole bunch of things we've never, ever seen before. Without a doubt. See, right here, we're looking at this right here. This is the quintessential nebula, not around any hot young stars that are irradiating it with deadly UV radiation. Okay, they are actually, this area is showing up only by the courtesy of subtle reflection from other nearby stars. And these cold, dark regions are the regions where, as I mentioned earlier, those little silica green dust particles accrete ices of all different kinds of elements and chemicals like CO2 and formaldehyde and ammonia and methane and other carbon-based materials as well. And then there's also in here there's carbon molecules, CC. Okay, hi Science Bob. And so those are the things that become the material from which new planets and new stars are born. Because amid all this is enough hydrogen to actually condense gravitationally to become a star. And that takes time, obviously, and it takes high temperatures. But the universe has time on its side. So eventually, I think we'll see potentially some stars forming in here. And that's the other thing that the James Webb is good at. The James Webb is good at seeing deep inside these clouds at wavelengths we have yet to be able to see at, and be able to catch what's happening deep inside the clouds. Because it's in the infrared where that's all going to happen. All right? And it's another stream, but the reason that the James Webb is only using infrared systems has to do with being able to see back to the time just after the universe became transparent. That's the time where the cosmic microwave background radiation can be seen. Okay, that is where it is. We can't see before that. We can't, and there's nothing that can do that. Okay, but the fact that is such, the fact that it's like that, and the fact that it's done that, the way it is, the James Webb construction, we're going to be able to see a lot more galaxies, because what happens is galaxies have these dark lines in them, just like stars do. They're called absorption lines. They're lines that show what the chemistry is, what the components are that make it up. Okay, so galaxies also have emission lines, and bright lines that show up, like from these like glowing nebulae, like the Orion Nebula, for instance. Well, that glowing nebula that has a bright lines for oxygen and hydrogen gas. Well, those objects inside galaxies also have bright lines that we can see. Well, what happens is, as galaxies get further away, they're speeding away from us faster. Now, to see that in an analogy, imagine a balloon, you blow it up to about, say, a softball size like this, and you put black dots on it. You take a Sharpie like this one, and you put dots all over it, okay? Just little dots. And then you blow it up. Every dot is going to move away from every other dot. However, as you blow it up, you'll notice that the balloon is blowing up in such a way that the dots at the other end of the balloon out here are moving away from you faster than the dots near you. Okay? So that's what's interesting about the expansion of the universe. It's inflating kind of like a balloon in a sense. Okay? So that speed at which these are moving out and expanding like this is something that's called recessional velocity, the speed at which something is moving out. All right? And when we look at such a thing, when we look at these things, what we're seeing is the lines that we see in the spectrum of these objects are shifted toward the red. That's called red shift. And the red shift is something that that takes the lines further and further and further. So the farther away galaxies are, the faster they're moving, the farther out those lines go into the infrared. So there are galaxies, when we look out into space, we can't even see them because all their data is far out in the infrared. And to this day, until James Webb is launched, there's galaxies out there we've never ever seen. And now we'll be able to see them because we're going to be able to see out in the infrared to see them. There we go. That's how it works.
These are
All
the
right, sorry about that.
Like when you look at the Hubble ultra deep field, when you see the very reddest little blobs way, way back in the background in the Hubble ultra deep field.
Yep.
Well, it's like those galaxies and the ones farther out that the Webb is going to be looking at. They're
That's right.
In the infrared
It's
back to visible.
That's right, and they're actually looking at for instance, they're looking at these galaxies that were just after the universe became transparent. That was a big black box. We've never been able to see that before. So we're going to see that. Now, the other benefit is we're going to be able to look into these dark nebulae that we've been looking at tonight so far. And we're going to be able to see a huge amount of detail in there like never before. This James Webb Space Telescope is 100 times better than the Hubble. It's got a 21-foot diameter mirror compared to Hubble's 8-foot. All right, and that right there is a huge difference. So we're in luck. We have nothing but good things coming up, I can tell you that. All right. All right, let's, we have Casper the Friendly Ghost here. We're going to go there. This is Measure 78. Let's close in a little. Here we go. This is another one of those beautiful dark nebulae. Here we go. Okay, now you see the telescope moving pretty wildly. It's going to be heading to a star, and then it's going to be going from that star. The star might be Bellatrix. It didn't go to Aldebaran. I'm sorry, it didn't go to Betelgeuse last time. Pete Bodge, yeah, the gold plate on the mirrors it's interesting. That gold plating is there because of two reasons. Number one, cosmic rays and gamma rays don't affect it as much. Gold is a really hardy material. But the other thing is, gold, as you mentioned, it reflects the infrared light very well. It makes all the visible light look kind of yellowy gold, okay, but it also reflects infrared light very well, so it really shifts it. It's beautiful. So that's an excellent excellent comment. Thank you. Yes, Raymond, this is the Casper, the Friendly Ghost.
NASA's had a really interesting series of videos about beryllium and why they made the mirrors of beryllium and where beryllium comes from and how beryllium is created in stars, or the fusion into beryllium. It's a really interesting series.
Yeah, the beryllium mirrors, okay, that's another thing right there. Beryllium, if you drop it, it'll shatter like glass. But beryllium is very, very strong and can withstand lots of structural, effects to it. And that's the thing that makes beryllium so likable for a project like this. This is called the Casper the Friendly Ghost Nebula, and you can see there's two pieces. There's one here, one there, okay? And what it is a really interesting reflection nebula, all right, like we said before. And there is it's a region of space where there's going to be some dark nebula that you'll see here shortly. I'm letting the telescope catch a guide star. So that's what I'm waiting for right now. I took the time while we're there to tell you what this is. Yeah. Casper, the friendly ghost. We talked about this last stream, Daryl. You mentioned the name of Casper's cousin. What was he?
Spooky.
Spooky, that's right. And there was another one
Spooky
too
is a tough
that
little
was.
ghost.
Yeah. Was he the short one with a cigar and a bowler hat? Is that the one we talked about?
Yeah, he has a black nose too.
Yeah, it's kind of funny. Okay, let's go and start this now. I have a guide star. And I want to do this. I want to make this, sorry, 35 seconds. 35 seconds. All right, 35 segundos. All right, and this is our settings. We got that going. Everything looks good. And we'll get our first exposure. Casper the Friendly Ghost is right near Orion. It's actually, is this in Orion? Let me see if I think it's in Orion.
It's a little bit to the upper left of Alnitek.
Yep. Definitely in Orion. I'm trying to see actually. Oh, we got a picture. Wow. This is going to be gorgeous. This is going to be
a lot of red
pretty.
in this one too.
Yeah, I'm going to do the color correction just to make sure, because okay, the red came down just a bit, but there is red in here. You can see over to the left there's this. I think this might be part of Barnard's Loop, actually. This part to the left up there. And we'll let this flesh out. This is going to be really pretty. Okay, telescope is stable. Let's check it out. Yep. You are absolutely right, Michael Klages. Michael, I'm pronouncing your name like Klages. Is it Klages with a hard G, or is it Klages with a soft G, like a J? Let me know. We want to get people's names right. What you already said there about this being probably part of the Barnard Loop here?
I wouldn't be surprised if it was. Certainly part of the Orion molecular cloud complex.
Oh, for sure. Yeah, this is all part of that. Yeah.
Yeah. Can you go back to Stellaria for a second? It would probably show it.
Okay. Let's back out. Let's get Stellarium going here. Oh yeah, there's
Yep.
Barnard's Loop. Oh, sorry.
Looks like.
I have a 1 second delay. Okay, so he says it's correct, so Klages is right. Thank you. There is Barnard's Loop. It's a loop of that's actually a remnant of an ancient supernova right here, and we're looking at an object right here, and this object here is called the it's actually NGC 2071 2068, I'm sorry, and Messier 78, but it's also a beautiful reflection nebula that's right near this supernova remnant. Now, near is just a relative term. I don't know how far they are from each other. One could be in the distance, one could be up front, one could be way in the back. So we don't know. Okay, so let's go back and check it out. What do we got? Oh, look at that. Wow, we're starting to get... Look at this detail right in here. Holy crap, yeah. That's beautiful.
There's
this
a lot
is
of
a beautiful night.
That star just above the brightest part, too.
Yeah, right there.
Loops and all around
right there.
Yep.
Yeah.
Higher up too.
Up there. Yep. Oh yeah. Interesting here. There's a little area here that's a little bright spot, and it's occluded by a dark piece of stuff in here. That's pretty cool. No, Michael, I actually, I've met so many people that I've learned how, I learned a lot about pronunciations over time, so I guess maybe that's why I got it right. I don't know. But I'm glad I got it right. I don't like massacring anyone's name, you know. This is beautiful. You notice how that modeling and that harshness is sort of leaving now, because as we stack more, and we're up to 8 images stacked now, as we stack more, and I'll bring this back in a bit, then we actually get a softer look because the noise is being knocked out, averaged out over time. Izabela. Yeah, but you had to tell me that it wasn't Sofia, Bulgaria. It was Sofia.
Right.
And I was embarrassed I didn't get that right.
I remember that.
Yeah.
Mark, have you got enough data acquired to start zooming in on it some?
I was just thinking the same thing, Daryl. I was thinking, let's see. I see a little color noise, but I think we can deal with it. Let's go to 75%. Okay, so this is the entire, again, just for the record, this is the entire size of the entire image that we get, okay? It's 4 full moons across and 3 full moons tall. Okay, that's 2 degrees by 1.5. Okay? So, if we look at it at its native resolution, if we go to 100%, then it's huge and it goes off the screen. But you can move to the different areas, but let's do it. So here's 100% coming up. Wow. That's interesting. We got some really neat detail in there. Let's move up a bit. You can see color noise and color modeling. That's something that has to go. I don't like that.
Those little light streaks down at the bottom right.
Yeah, right here.
Look interesting too. Yes.
Yeah, it's pretty cool. Okay. Let's go back to 50% for a moment. There we go. This is stunning. Interesting, these 2 stars down here, these red ones. It looks like those stars are behind some dark dust, or they're red dwarf stars. But you can tell, sometimes you can tell the difference because the red dwarf stars are actually pretty red. And these might be red dwarfs, but whereas these might be just stars that are suffering interstellar extinction. Because of the dark dust that they're being seen through. You know, if you think about it, take a look at how much stuff there is, and then out here, it's like you see nothing. Okay, but there's stuff there. You know, the interstellar medium is anything but empty. Space is anything but just space. There's a lot going on there. Okay, let's back out to a full screen here. Again. And
Mark,
let this stabilize.
Me a moment, please.
Sure, go ahead.
Michael Klages and Science Bob are asking about your camera.
Okay, sorry guys. So first of all, this system is a F2 system we're running. Okay, we have a Hyperstar on a 10-inch LX600 out in a building in Arizona in the desert. And we're using a ZWO ASI 294 MC Pro, which I think is the best one-shot color camera on the market, to be honest, for this. So that's what we've got on there. And the previous camera that we used to use was a Sony A7S II. And I discovered that the Sony A7S II was just not up to the task. You know, it had a problem with what's called the star eater. These faint stars you see in this image, they might have been knocked out because the algorithm would have thought it was noise, and we couldn't fix that. There was no way to do that. But at the time, it's all I had, and it was really, really beautiful. So in the other telescope we're going to put out in that building, we're adding a system with a filter wheel, and we're going to have narrowband filters, and we're going to be able to do narrowband imagery. So we'll have a hydrogen alpha specific filter, a sulfur specific filter, and an oxygen 3 specific filter, and we'll be able to do that kind of thing, and build our luminance channels and all that, and do it, you know, with separate stuff. And that way we'll actually be able to make native Hubble type palettes if we want to. But I don't know if that's going to be something people are going to be excited about. That's something that I'll be excited about as an astronomer. Okay. But we'll see. I'm looking. This is really interesting right here. What's going on there? Yeah, check that out. Come on, let's go in there. What do we got going on here? All right. Gotta let this... the pixelation sometimes causes a problem. It has to do with the throughput of the data. Okay, that's this guy. Look at this dark cloud. All right, and this stuff is just... This star is probably in that cloud, peeking through, and its data is reddened. Its starlight is reddened. This one you can see is actually illuminating the cloud, but it's probably on this side of the cloud. Again, not on this side. So on this side, you can see more of that light. So it's not as reddened. Very, very interesting. Remember, the universe is in 3D. Yeah, I could go mono, but mono's not as exciting. Obviously, if we do it like I was saying, then I would probably do mono shots, you know, for sure. To actually do, oops, sorry about that. To actually do this as a system that's doing full, true narrowband filters, and then combine them in the program. That's probably the best way to do it. It's proven, anyway. All right, let's go see what we got. We should have how many? 20? 21. All right. Gosh, that's beautiful. That's really, really pretty. So we're going to save this FITS file right here. You'll see the blue bar across the top, or the green bar. Boom, there it is. Then we're going to save this exactly as seen, just like this. Boom. And then you'll see the ping file, PNG. So that's a regular graphics file. If you don't have a FITS viewer, then that's for you. Okay. Let's see now. Now we're going to get rid of this, and we're going to go back to a 1 second exposure. And with the 1 second exposure, not 1A, 1S, do it right. Okay, and that's going to give us our 1 second shot. And then I basically really do what's called a big stretch. And that stretch shows us the sky and as if you were looking at it through an image intensifying system, just to give you a better idea where we're looking. And I always have to look at where the telescope is going before I actually do anything. So I'm taking us out of this mode. I'm noticing it's taking some time. We're waiting. You know, there's some issues, I guess, with the bandwidth. Starlink is on order. We're going to see Starlink in a few weeks, actually a couple weeks. Yeah, the images, Izabela, are taking time. That's correct. But it's all right. As long as it doesn't kill me like last time. I had a back-end issue with the company that runs our software to go computer to computer from this place in Connecticut to the observatory in Arizona desert. And that was a problem. That caused problems. So I'm waiting now, getting delays. It took long enough. That was like an 8-second delay. And I had pressed it once already. So, so let's try again. Yeah, the delay is killing me. I can't stand this. That's the only thing that happens sometimes. All right. Oh. All right. One click and one click only. Not touching it now. That's a lot of time it's taken. Okay. Why don't we see if we can actually go to Alnatak right now. And then we'll go from there and move to the Horsehead and the Flame and just have some fun. Okay, so now we're going. The telescope system out there, by the way, is all solid state. It's very fast. So that's not an issue whatsoever with this. Okay, to go to Alnatak, it's going to Bellatrix first, and that's normally when you go to stars, they go. I must have picked something other than Alnatak. I thought I had it though. Yeah, I had Alnatak in there. So it's going to auto center Bellatrix and then precisely go down to Alnatak, which you'll see momentarily. And there we go. And look what else you see. We've got the Flame Nebula right here. Got the Horsehead right here. Oh yeah, and that's Alnatak, Alnilam, and then Mintaka. So we have Alnatak, Alnilam, and Mintaka. So these are two of the belt stars in Orion. Okay. I'm just waiting for it to calm down. There we go. Now we'll just shift it over to the east a little bit. Move the telescope over. So think of it as you're looking at the sky and you're going to move to the left, which is toward the east. Okay? And now we'll bring it up. Okay. And one more little jog. Okay. Now, this is Barnard 33. It's the Horsehead Nebula. And this wall right here is an edge to the Orion Molecular Cloud Complex, okay, which is all throughout this whole region of space. A lot of other crazy things going on here. Hey there, JSCO. How are you? So let's go bring that. Let's go bring that to fruition. Let's actually give ourselves a really cool image. Let's do we'll do 30 seconds because that'll show us some really interesting detail over here. There's some really cool stuff over here that's neat that people don't often get to see. So we'll go out of our high-res shot here. Actually, our what I call a finder, our intensified finder. And I'm going to say clear, and it's automatically going to get ready to go. So now what we'll see coming in will be pretty. Be ready. This is going to be gorgeous. Oh, yeah. Now, not bad for a 30-second shot, but as we talked about, look at this.
Yep.
A satellite. That one's probably going to go that way, so we're going to just have a dash to the left a little bit. This is highly stretched. We can actually fix that a little bit by doing that, dragging it out a little bit, and then I think the color's pretty good, but we'll affect the color a little bit too. There we go. Now we'll see it looks softer and prettier. One of the things to notice is inside this beautiful reflection nebula, there's a complex collection of knots of dust that we actually could catch. Hey there, Blues Traveler. How you doing? Fantasy, how are you? Good to see you. JSCO, what's going on, brother? I said hi to you, but I sort of talked to you. I didn't say hello. Now, this star here is, as Darryl will tell you, one of his favorites. It's Sigma Orionis. And it's a very bright star, but it's also one of several stars. And I think you said it was a sextuple star? Six components?
Yeah.
Okay.
Several of them are several of them are spectroscopic binaries. They're so close together you can't split them by eye.
Yeah, which makes sense. Fantasy says he's getting ready to be timed out by you again accidentally.
Yeah.
Yeah, he didn't mean that. We're sorry, man. That was something that he didn't mean. But you know what? Hopefully I made it so you don't have to worry about that now. Okay. So there's the beautiful Horsehead, and there's the flame. You'll notice the flame is slightly different in color. And that has to do with the fact that this coloring is probably being seen through some of the clouds of the Dark Nebula. You know, this here is being seen through mostly a light veil of Dark Nebula. All right, this is much more pronounced up here. Greggy Gilgan, how are you? Nice to see you. Greggy is from Australia. Great to have you here. Michael Clegg is, well, you know what, though, Michael, it really comes down. He says that 30 seconds is as good as my 1.5 hours. Well, to be honest, doesn't matter. I mean, you're getting the results. I'm just doing, see, the reason that I wanted to get this type of equipment in place is to bring people the universe as quick as possible. Because, I mean, there are people that watch this on big screen TVs, you know, and when they do that, you know, this is cool. I teach classes with this observatory, and you can't sit there for an hour and a half, you know, but it's okay, you know. I'm happy though that you do it. Really am. I've got some other things here. I could do an image boost. I'm not. It's probably not going to look that good. Yeah, I don't see a difference. Let's see a boost more. It's probably going to make it just brighter. Well, I actually won't do it. You know, I don't think it's going to do anything without because it's just, what the hell just happened? Oh, sorry. It'll be there. My stack will be back. Don't worry. I got out of the stack for a minute, but it doesn't hurt anything. Yeah, that's pretty. I want to show you, though. Let's go take a look right here. This is neat. This is the coolest thing. We've done a stack of 8 of them so far. Yeah, no, that's great, Michael. And you know, 70 millimeter aperture. Yeah, I mean, you're going to be there a while, but so what? And it depends on the speed, too. You maybe have it's like an f8, f10. I used a 20-inch refractor that was like f19. You know, for years working on a parallax program in a big observatory. Check this out. So look at this beautiful little tendril right there. And this star here is sort of evaporating it. I think that's what we're seeing here. But look at the detail in there. Isn't that cool? These become, you know, and there's hot spots in here, Daryl, right? Stuff like that. Same thing with this. So there's a lot going on. And if you look at the Horsehead right here, you can actually see, too, that the Horsehead has these beautiful wisps hanging out underneath it and all throughout it. In the main here, it's just incredible. Just incredible. Beautiful. Just a gorgeous area. I mean, it never gets old. Well, that does. Satellites get old. Go away. But that's beautiful. And this here, you see, this is a darker nebula here. You can pull that all out. This is like a billowy pillow here. And you can tease all that out. And let me see if I can actually make a little bit of that happen. I might have to do it this way. Let's see if that helps me. Does that tease some of that out? Yeah, you're starting to get a little of the billowing there. You lose a little bit of this, but you see this much better. Look at that. See that detail there? That's crazy. I mean, that's really good detail.
That one little finger up there in the cloud around
there.
The star on the right, that's I guess what's happening in like the pillars of creation. If that star is evaporating, what's
I think so. I think this star, like we've talked about with pillars of creation, if I'm reading this right, this star, of course, young hot star, but there's hydrogen gas in here, but there's a lot. In this case, it's overwhelmed by the dust that's in this area, most likely. And this has stellar winds that are blowing the dark dust back and creating a cavity around itself. That's what it's doing. And that's what these stars do. They create cavities around themselves. If we look at this other one over here, all right, we see, let me just go back. I went too far, I think. Okay, this one is creating a cavity around itself as well. Okay, but still, these cavities have resilient material in them. They do have like this finger here of dark material. What's happening is this stuff up here at the front end here, that's probably really dense. Okay, and so when the star is trying to evaporate it, it can't do it because it hits the front, but then it can't get the back because it's being blocked by this thing. We see that in some cases. That may not be happening here, but I just think this is just incredible. Hey, Dean Bustador, how are you?
Did you pause the live stack?
No, I didn't.
Says
Did I do that?
Yeah, the yellow banner across the top.
I see it. Yeah, I see it. Let me see what I did. Oh, resume. I must have stopped at 8. Okay. No problem. See this see that when you zoom in here, this is called color noise. You see this modeling here? Okay, this modeling that you see in here. That's color noise. It's really not there. So what we want to do is we want to average that out to what is really there. So as we keep stacking on top, that's going to get averaged to something that actually is more what it is. If you take one frame, there's a lot of noise in it. Yes, Izabela, this is a reflection nebula. 2 of them. In the Horsehead, yep. 2 of them. But you'll notice that you've got these other nebulas as well. This is a very complex nebula. It's what's called an emission reflection nebula, okay, this whole complex area, just like the Orion Nebula is. There we go. Let's take this out. Take us home, Barnard 33, otherwise known as the Horsehead. Oh, man. I mean, where else are you going to see something like that in 30 seconds, You can almost see the 3D nature of the Flame Nebula tonight. You can almost see a semblance of the depth, That is just beautiful. Just beautiful. Wow. 12 stacks so far. Here's more detail here that's just beautiful. And it trails off here, but it doesn't trail off because the hydrogen's gone. It trails off because the star's influence can't reach it. Okay? So that's what's going on there. So do you guys like this stuff? Let me know.
I do.
I know you do. That's good, Dean. I'm glad you're doing great. Thank you. Yeah, Science Bob. This looks great on the 72-inch. Yeah, a lot of people do put them on their big screen TVs and just sit back. It's like watching a movie, you know? Except you can interact with it and talk to it, and it'll talk back sometimes, you know? A.R. Lemieux, how you doing? I'm glad you're watching. Thank you. Hey, get my screen back. Don't do that.
What happened?
I don't know. So, apparently that happened. That happens sometimes. Okay, we're at 14 stack now. I'm just going to pop out to watch it, see what happened. Okay, there we go. All right, Michael, I'm glad you're liking it. Fantasy, yeah. Nebulas are beautiful, aren't they? So we've done 15 of these. Do you think it's time to go to the Orion Nebula? I want to take you to the Orion Nebula, then we're going to go south of the Orion Nebula because I want to show you everything that's down there. A tremendous complexity of dark dust down there. Tonight is a dark nebula night because we got it. We can do it, you know. So, yes, this is an emission in dark nebula, but obviously you can see. Let me just bring the. Let me just do some manipulation here real quick. Okay, do that. Come out of this. And then we go back. All right, and then it'll. Yeah.
Think you might try the
Oh, thanks,
Head
Blues
again
Traveler.
tonight?
Sure, actually. Blues Traveler, thank you. I've learned so much from you in the last few years. Thank you. And you know what? You're more than welcome, man. You know, and like I said, you know, Skyter Livestream started with me, but it's not me anymore. I mean, it's Daryl. It's Amanda when she can make it. You know, it's Marianne Robb, who was a primary mover and shaker, business development for us. It's Tara Deulis, artist who manages to do all kinds of creative things on behalf of Skyter Livestream. It used to be just me, you know. So I take the compliments and share the credit for sure. It's not just me anymore, and I'd be arrogant to say it was. But thank you. On behalf of all of us, thank you. You know, we're not getting anything for this. We're not making money on this. You know, we're just doing our thing. We want to actually create astronomy curriculums and actually teach astronomy live. I mean, going to a nebula like this is a perfect place to go to teach how planets form and how stars can form and what they do, how they actually affect nearby gas and dust and the clouds. That's a great thing, great stuff. You know? Yeah, thanks, Blues. That's funny. Hey, there's Adarak. What's going on? Donald Kunzer. That's cool. Thank you. So what I'm going to do, we're at 20 stack now for this, and that's pretty good. So what I'm going to do now is I'm going to pause this stack, primarily because I'm impatient. I really want to go see the Orion Nebula and more. And I'm going to save this. There's the FITS file note up there, and then we're going to save it exactly as you see it. And it may take a while, only because of the transmission speed right now with the internet. But oh, goodbye, clear. Oh, but don't worry, it's preserved forever on the server where you can get it for free. Izabela, if you could put the server location back up there, that would be great. you can go to the server and you start digging down through. I did maintenance on it, so I only put the latest, best ones that are up there now. You can dig through there and go down into the directories for each object. They're labeled by date, and those will actually be up there in a little while. And if you want to just see the pretty pictures, then the directory you want to go to in each of the different directories is one labeled processed. It's in the description for the stream. All right, it's in the description for all the streams. It shows you where to go, gives you the link, so you can do that as well. I finally got smart about that. It only took me a year. Okay. Telescope is performing well tonight. I am pleased. When I got in earlier, it was not aligned. Something was wrong once again, and it did some weird motion where it started moving on its own. But I corrected it. I did a plate solve, let it tell me where it was in the sky, where it thought it was looking at, and then I set those coordinates, and we're smooth sailing. It never used to. It used to be a lot harder than that.
I'll say.
Yeah, you were there. You know. All right. Okay, let's go now down to the Orion Nebula. Great, googly moogly. The Orion Nebula. There we go. And away we go. Let's see now. What stars are going to take us to? Probably Saiph. It's probably going to jump down the Saiph. Oh, it might go to Rigel. Let's find out. Doing high precision slewing. No. That looks like it's going to be Saiph. Oh, Cursa. Duh, yeah, okay. Cursa's another star that it typically picks up. Oh, no, it wasn't that star. Yeah, okay. So it's auto-centering Cursa. There we go. No. Thank you, Raymond. That's kind. Art and science on the server. There you go. Thank you, Izabela. All right, and now watch this. What comes in? It's gonna be like, whoa, you know, where'd it go? That's funny. Hang on.
Knock on wood.
I know, right? Let's see where it went. We're not lost. Oh, okay. It went down here. Well, that's really strange. I don't know why it did that. But it's not a problem because I can get us back there again. Okay. Let's just head up north. All right, I can get us faster.
So you talked about the scope losing its position, and did it lose its position?
No, it still knows exactly where it is. It just didn't know where it was going from Cursa.
Oh.
For some reason. I don't know why.
Reminds me the Charlton Heston, Brian Keith movie, The Mountain Men. Brian Keith said at one point, lost? Hell, I ain't never been lost. I've been damn confused for a month or two, but I ain't never been lost.
Yeah. Okay, stop. I'm going to get this back here now. Okay, let's shift eastward now with a little bit gentler tack. Raymond, thank you, by the way. It's very kind. earlier I told you about a nebula that called the Running Man, which is this one up here. It's called NGC 1977. And the Running Man is a really interesting nebula because it's a reflection nebula. But what it's doing is it's the blue light from the stars is being scattered. And that's why these nebula are blue. Okay? When you see those, that are called reflection nebulae. Now, in addition, it also has emission nebula, which is red inside of it. And so the red of the emission nebula coupled with the blue of the reflection nebula, it's in light, it works different than paint. But when the light mixes like that, when the light passes through it and it goes to your eye perceives it as purple. So this nebula here will have a core that will look purple to you. All right? So let's do this. Let's bring this over. Hey, Science Bob. Thanks, man. Yeah, this is beautiful, isn't it? Thank you so much. Okay, so now we're getting...
Thank you, Raymond.
Yeah, Raymond and Bob, you guys are great. Everybody else that's, Vera as well, just phenomenal. You guys are amazing. Okay, so let's do this. Let's get out of our hybrid mode here, so we can just see the nebula like it is, right? And then I'm going to zoom in to see how our focus is doing, because I check once in a while, but like I say, it's focusing on its own, but I want to make sure that it's still focusing correctly. And it looks like it's reasonably good. I'm going to still, moment to moment it changes because of the atmosphere, but we got a pretty nice view. Oh yeah, let me, I'm going to drop the exposure now down to just 70, or actually 50 milliseconds. And I'll tell you why. Because I want to show you what's powering this nebula. And there they are. It's the Trapezium. These are 4 hot young stars that are powering this nebula. And let's go to 200%. This is live, so this is happening very live. So I'm going to also affect the focus here. Okay.
It does look a little soft.
It is. I'm about to change that. All right. Okay. Temperature is 55.2. And I'm going to change. I'm in a different mode right now. I'm in a learning mode. I've actually done something a little different. And let's drop the focus and see where it goes. See if it's going in the right direction. Looks like it is. As you can see, the trapezium is getting better. That's 48,200.
Looks like it's getting worse now.
Yeah, no, I went through to go back. Oh, Vera, that's very kind of you, but thank you. You being here is more than enough, and I thank you for that. Okay. All right. All right, so let me just work it back now little by little. A little more. We have to let turbulent air cells get through, you know. That looks pretty good. In between the turbulence, you see how that's not bad? You see all 4 components now? See all 4? 1, 2, 3, 4. You can see all 4.
Barely see the 4th one, the one at the top. Comes and goes.
Yeah. Let me just see if let's go to 29. See if that makes any difference. That's the wrong way. Yeah, I think that I think this was getting a little better.
I think that was better there a second ago. Some of that is turbulence, though, as you said.
Yeah.
Get quick little glimpses where the 4th member up
good.
at the top stands out a little clear.
Yeah. 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 So we're getting some turbulent air right now. So I'm waiting it out.
Turbulent air is one of the downsides here in Colorado for astronomical viewing, especially in the mountains in here on the Front Range. The air coming off the mountains really gets disturbed by the mountains and makes it very turbulent. We tend to have very clear, transparent skies here, but very turbulent, very poor seeing because of the turbulence, because of the mountains. And I found in my experience here, a lot of people say, oh gosh, you got to go up in the mountains to observe, and I found that you actually get better air if you go out east, like an hour and a half out east, that the air has a chance to settle. Yeah, out on the plains, air has a chance to settle down again by the time it gets out there.
All right.
Okay, plus you don't get the huge temperature swings either.
Okay, now with that, I'm going to do a I'll just start with a 20-second exposure, right? And this is the reason for that is because I want to show you the basic colors of this nebula, which are really interesting because the colors of this nebula indicate some very, very interesting chemistry going on in the interstellar medium. By the way, when we look at these clouds of gas and dust, we think of them as like big, dense clouds, right? Well, the truth is, and we'll see, of course, I have our inevitable satellites. We have this trio. This trio runs through quite a bit. These are, I think, Navy birds, Navy ranging satellites that are going through right now. DOD, DARPA type thing. All right, so let's do this. Let's give ourselves a little more range and soften the edges so you can see what's going on. Hey, One Man, how you doing? Okay. Now, when we look in the Orion Nebula, and there's more we'll see here shortly. I'm showing you just the nebula. Let me just affect the color a little bit. Okay. As I said, if you look at the Running Man Nebula up here, it's a blue nebula. That means that the starlight here that you see is scattering the high frequency or blue light from the stars But those blue stars are also causing this nebula to glow in here, like the red you see here in the Orion Nebula. But what's going on up here is that we're looking at this purple showing through the blue. It's actually red showing through the blue, and when the red shows through the blue in the light, the light mixes to the color purple, and that's kind of why it looks this way. You know, that's exactly why it looks this way. Here we don't have that going on, so we just have the light that's red coming from the hydrogen emission. And there's Bill Murray eating a Baby Ruth candy bar, according to Daryl. I don't know how he sees that. I just don't see it.
I can't see that so much now. It's a little bit overexposed in the middle of the nebula.
Oh, then there's a way in which I can keep you from seeing it. I like it. All right. Let me do this. Let me just pull this data down a little bit, just to give us a little more. Let me actually do this. I'll go the other way. Okay. Yeah, there's a lot going on in this nebula. And there's a lot going on right here. All right. Do you notice this billowing clouds here? Billowing clouds of dark dust. Dark dust all the way out into here. It's just incredible. There's a lot going on in the Orion area, the Orion region. Again, think of the Orion Nebula as sort of like a blister on the edge of a gigantic molecular cloud. That molecular cloud being all throughout here. All throughout here and all throughout here. All right, and this here is up front, sticking its face right out looking at you on this molecular cloud. So it's kind of like a blister on a molecular cloud. And this greenish blue color you see here, right, this is actually, especially this area, okay, this is the light of oxygen. All right, oxygen glows bluish green, like right here especially. Oxygen glows bluish green when it's ionized, when oxygen is ionized, doubly ionized in fact. And hydrogen, as I said, glows red when it's ionized, and that's what we're looking at there. So this is called an emission reflection nebula as well, because we also get the scattered light of the stars as well, the scattered blue light from the stars, in addition to the oxygen, in addition to the hydrogen, and in addition to a bunch of other chemistry going on in this nebula. Okay, Orion Nebula is known as a stellar nursery. It's a location where stars are being born. In fact, we have seen stars. The James Webb Telescope is going to look here as well and look at these young stars that are forming there. And they're buried inside the nebula right now. You can't see them at all with this telescope or most any other. But if you have a good infrared telescope that can see way out into the infrared, just like the James Webb, then you'd be able to see it. And that's what we're looking forward to. Look at this beautiful, you can see this beautiful brown. Let me move myself out of the way here. In fact, let me do this. Let's just make this really expansive just for a minute, shall we? Yeah, there we go. Okay. Now, if you look right here, okay, you can see, let me just go over there. Okay, you can actually, you can see this beautiful dark area, okay, and it leads all the way down here. See this right here? Okay, this all is very, very beautiful in here. And it makes sure that you can see this brownish tone to this material. So I think that's pretty cool, you know? I think that's a pretty interesting finding. And the other thing is, let's zoom in now a little bit. We've stacked, let's see, we've stacked how many here? Oh, 16. So let's go to 75% and move around this image, shall we? Okay, I can see that we need a little bit of guiding help here. I have a little problem with the guiding. The auto guider's not quite calibrated right, but that's okay. See this? There's that billowing, beautiful brown material I was telling you about. Right. So here's what we're going to do. I'm going to get out of this for a moment. All right, and drop us back, and I'm going to go in to the telescope, and I'm going to go make a guiding adjustment. Well, you're getting coverage when you start getting spammers coming in and trying to leave stupid web links. All right.
It's been happening in a lot of places on YouTube lately.
Yeah.
They've gotten particularly
I don't know what
bad.
I don't know what they think they're going to get out of it. They're not going to make any money because no one falls for it. So it's like, that's just pretty stupid, lame. We just see them as the morons that they are. Okay. All right. So I set the rate now on the equator. We're kind of near the celestial equator, so any guiding errors are going to show up here. Pretty easily. When you're up north and south, you don't really see the guiding errors. Look at the beauty in this image. Isn't this beautiful? And here I am about to just wipe it out and start again. But it's going to serve a purpose because when I redo this stack, I'm going to clear it and restart it with the new settings for the guider. So check it out, because when I redo this now, what you're going to see is a very different image. Because the image you're going to see right away is one that doesn't look very good. You're going to say, ew, that's terrible. Okay? And it is. If you look at it, that's kind of terrible. All right? But the stars are round. Okay? And the reason that they look this way is because of this noise in here. There's all kinds of modeling and noise. All right? But you see this progress bar over there? Okay, watch now. Watch right here. Watch. Here we go. As this gets another one. Watch. Okay, do you see that? It starts cutting down the noise because we now have 2 frames that are stacked here. And when three are stacked, it's going to get less and less and less, and the noise will go away. And that's just what we're looking for. It's going to be very pretty. We'll be able to get much more data out. Look at that. The noise just went away some more, and now these clouds are showing up very, very brightly and much better. This is stunning. It's an object all in itself that you can just look at that dark cloud. And look at more satellites.
Jeez.
Well, near the equator we always get tons of them. I've never been able to image Orion without seeing satellites now.
They're always moving west to east.
To the east. Yep. Yeah. And it's interesting that these satellites, though, are probably not Starlink. Because Starlink satellites actually go northwest to southeast, northeast to southwest. They, some east-west, or west-east. But Starlink is making a Tholian web around the Earth. That's what I'm calling it, It's like a Tholian web. But these trails, they're going to be gone in just a few more minutes of stacking. They're going to go. So that's okay. Wow. Okay. Isn't that gorgeous? See, now, probably for the first time, you can see how this is all one big giant nebula. It's one big giant nebula. They're all connected in a sense. Thank you, Raymond. Noise reduction fee. You're funny. Thank you so much. Yeah, if you can just block those guys that just put those stupid links in. I don't know if you can just block them or kick them off the channel. I don't know. Maybe that's what I got to do. I'm not sure. Yeah, okay, well. I hit him. So he can't ever come back. Raymond, you're the man. Thank you. And all I did was show a beautiful nebula. So this is 11 stacks. 11 stacked images so far. And when you look here, you can actually see this beautiful oxygen cloud, this greenish blue. It's just a stunning color. Lots of oxygen here, especially right here. And with an amateur telescope, you can actually capture beautiful arcs of oxygen here and here, and then you have the H alpha, or the hydrogen alpha, the red hydrogen gas here. It's really beautiful. Oh yeah, that's just beautiful. Yeah, Dean, there's a few spammers that come in here, and that's good. Yeah, I look at it as, hey, I'm getting the channel noticed by somebody, right? Yeah. And 42 did it. You're right. Thank you, Raymond. Yeah, let's go and go to 100% now. We only have 14 stacked, but that should be okay. All right, let's see how this looks. Okay. Okay, let's let this stabilize. Wow, that's just beautiful. That is the area between the Orion Nebula and the Running Man Nebula. And I'm going to just zoom out just enough. Oh, OG says they're spamming bots. Okay. What are they putting in there? I mean, that looks like a link, but it's not a link. What's the whole point of that? Look at that. You can see how this is dust that's being illuminated by stars that are in the Orion Nebula down here, and they're not actually glowing like blue like this. So this is dust that's not in direct contact or illumination by high frequency light coming from these stars. It's reflected light, which is what the brown is. It's just pure reflected light. That's an area that imagine cruising through there with a spacecraft. You probably wouldn't even see any of the brown clouds because you'd be inside of it. And just so you understand the density of these clouds, we're talking about anywhere from 30 to 300 to just 1,000 molecules per cubic centimeter, as opposed to millions and millions and millions of times more in just like air. Okay, so we're talking a lot of density difference. Yeah, you're right, Raymond.
I'd like to ask a question.
Sure.
I noticed in chat nobody's complained about my channel beeping tonight. Has anybody heard the beep beep sound? If I go back and review a stream, I never hear it.
Well, what it is, it's a high frequency. It's a high frequency sound of like some kind of interference, and I thought it was because of the way your cables were going for the microphone or whatever. So apparently you changed them because I don't hear it anymore. It sounds nice and clear now.
I'm really not doing anything different.
Oh, you're supposed to say, "Oh, I changed the route of all my wires." Look at this beautiful nebula. Look at this, Daryl. Look at this detail out here, huh?
Oh, yeah.
That's just beautiful. Now, see, it's a Let's go see. Vera says you're perfect. You know, it's a trade-off, guys. All right? Because when we actually try to... thank you, Ray. Them Running Man blues, yeah. When we try to take a photograph of the Orion Nebula, we could take a picture of the interior here. But then we don't capture this out here. So you do both. You know, you have to be cognizant of it, and that's the problem. It's not that easy to take a picture of the nebula and capture all of it. You have to actually do it in sections, and then what you have to do is make sure that you take a photograph that's just a short exposure, and then somehow blend it with the longer exposures, which people do. You know.
That's one of those things, though. I guess you'd call it dynamic range. That,
Yeah.
you know, I know if you look at the Orion Nebula by eye, you know, you can still see the really, you know, the brighter stuff and the dimmer stuff at the same time.
Yeah.
And it tends to get lost in the exposures with imaging.
Yep. Okay, what we're going to do now is, again, this is heading up to the server. What we're going to do now is go south and drop down. Then we'll move over, hopefully, to past Rigel to look at the Witch's Head again. So we stacked 27, and I just saved them. Let me do one more thing here before I do that. Okay, that one kind of showcases the bright edges here very nice. I'm going to save that as well. Oops. It saved the stack. I didn't need to save that. There'll be 2 up there. They'll be exactly the same, though. All right. So now we can clear this one. Go back to 1 second. Drop down. All right. I think you'll like this. All right. There's a 1 second shot. Not bad for 1 second on the Orion Nebula, huh? It's just like, wow. It's like, wow, I don't know. Holy cow. Christopher Walken, right? Doesn't everybody do Christopher Walken? Hey, that's not how you talk to my friend here, you know? Remember Joe Dirt?
I never saw
Okay,
Joe
let's get
Dirt.
rid of this. Okay, let's get rid of this stack here. Alright, get out of that. Alright. See, look at that. Now that's really pretty because of that. Okay, now what we're going to do is we're just going to go down a little bit. Orion is still going to be visible. Okay. I think I got it. No, that was right. That was done. So what is the reason that... Are we still a delay here? No, okay. So we're going to go down just a little bit south of the Orion Nebula. We're going to keep it just at the very, just the bottom parts of it at the top of the field. Because now I want to show you something even more incredible. Well, it's not more incredible, but something equally fascinating. Fascinating, Captain. All right. So, there we are. All right, we're there now, Captain. So what we'll do is get the trapezium just off of there. Just get the feathers of the Orion Nebula in here. There we go. Okay, now we're going to do a 30-second exposure. And I want to show you everything that's going on down in there. There's so much dust in this region. It's outrageous. It's just beautiful. Okay. So the stack now, I clear. And the progress bar is down there. See that progress bar? As it fills up, our exposure is being captured. And it doesn't matter how many times they clear it now, because it's data that's on the sensor, and the sensor data is read off at the end of each exposure. So now let's see what we get. All right, now let me do a little bit of a stretch here. Okay. Okay, now we're getting more nebula. I want to actually... That might work okay. Look at all this dust, and it's going to just get... It's going to get even more. See, I thought I was off the nebula, and I'm not. Hang on, let me just go back to auto mode. Let's check it out. Okay. All right, so let's do this. Let's go to 1 second again for another minute here. Another second. And get rid of the live stack. All right. And now what we're going to do is do a little hybrid view. And then we're going to go south some more.
Maybe get that bright star close to the top edge.
Yeah.
It's right
I
at
did
the
that
edge
last
of the
time.
M42 nebulosity.
Yeah, and it's actually, there's more. This right here is called the 13th Pearl. It's actually a really cool little nebula, tiny little nebula. But this whole region right here is chock full of stuff, man. And I'm going to show it to you because I'm going to actually go this way a little bit. Take it all over here. Just a little bit. Okay, if you look where our telescope's pointing, you can see the telescope's actually pointing pretty high up, so we're good. Okay, so this guy here, we're going to overexpose that tremendously. We're not going to be able to see that. It's going to look like a one bright star when we're done here. But let's go in here and just do another 35 seconds. Right, and go for it. And let's bring up our stack. We're going to clear it because I think I had something in the buffer. And we'll clear this buffer. And there we go. And the next object we'll see after we look at this for a bit is we'll head over there and check out the Witch's Head Nebula. So we're going to go with that star. Yeah, Chrystal Ball. Alright, so let's go back here. Here we go. Wow. Yeah, see, look at this dust. And this is just the first exposure. Just wait until this fleshes out. It's going to be an incredible amount of dust. I think the last exposure I said I did on this was like 55 seconds. But we don't need that long to check to get this to see what we want to see. Okay. Okay, let's get at least 2 frames stacked before I stretch it here. Okay.
That's not a knife. This is a knife.
That's a knife. That's right. Yeah. Oh, that ain't a knife. This is a knife. Huh. Look at this.
That's
Look at this
nice
beautiful...
right there.
Yeah, and this is that 13th Pearl Nebula we were talking about that looks like a star. And you can see that it's a reflection nebula, but you can see that it has dust here, but more of it's energizing, or its light is being scattered by material behind this forward veil of dust. I mean, universe is in 3D, remember? Isn't that something? Look at the billowing clouds here. It's almost like these clouds are just billowing. Incredible. just something. I'm telling you, this is really nice night. I'm glad that this is working to our advantage right now. It's what time's the moonrise? 11? 11:30?
Down there, 11:40.
Okay. I think we'll be done before then.
You've got about an hour, 40 minutes.
Okay. Thank you, Raymond.
Raymond, you're going to eat cat food again. Almost.
No, you can tell. You can tell Raymond is actually very, very energized by this stuff. I need 100 Raymonds, and then we can take care of our internet bill at the observatory. I was thinking of starting a Patreon at some point, but I don't know. I don't want to have people constantly donating money. I'd rather have somebody like a foundation underwrite it. You know, I'm working on a couple things. I'll be talking to people Tuesday about it, so maybe I'll be able to work something out.
Oh, a lot of people are doing Patreon now.
I know.
And a lot of them are offering special features that you don't get on the regular stream.
Yeah. Well, one of the special features. Yeah, one of the benefits I wanted to actually, when I was thinking about it, is I would like to offer someone out there to come on and basically drive the telescope. Where do you want to go? Take it, man. You know, I'll be here so you don't like run it into the ground or anywhere where you can't run it. You know, so that's one of the thoughts I had. So there's a possibility. JSCO, you talking about this right here?
I assume that's
that right there.
What is that? Back scattering? Forward scattering? It's
well,
like
this
the blue
is
reflection nebula.
It is. This is a dust veil right here that's I think blocking this star. This is the 13th Pearl. This is that star that has a little nebula within it. A little nebula. It's sort of buried within. But at long exposures, it looks just like a star. You'd never know. But okay, JSCO. But this right here is a reflection nebula that's actually scattering the hot light. The high frequency light from a star, probably this one. But it's scattering back. Okay, it's the brown stuff is occluding in the front, but it's scattering into the back, and you're seeing this greenish blue or this bluish reflection nebula back here. Okay, and then the star is up here in the front. Okay, but it's also affecting what's back here. That's kind of what I think is going on there. So that's kind of cool. But look at how much there's clouds. In fact, if you notice, there's like only clouds. You know?
Yeah.
It's like there's only clouds. All right, let's take our dark level and just ever so slightly shift it.
Excuse me for a moment, please.
Sure, go ahead. That's something else. Let's actually zoom in on that section here. Yeah, Izabela, you're going to have a lot of work. Oh, so am I. Okay, so as we zoom in, now you can see better what's going on. This is a star that has this dark nebula right in front of the... it's part of this really, really bright nebula, but it's also going back, and the light from it's being scattered by the dust back here, too. Really interesting. Very impressive. Most impressive. And it is a Jedi. Okay. It's like we're looking at a close-up of like chocolate pudding or something. You know, it's like, I don't know, with sprinkles. Starlight sprinkles. Oh. I also see we have a focus issue too. Arrgh. Alrighty. I'll fix it all. All right. All right, we got 12 stacked. That's good enough for this. All right. Let's save there, and we'll save exactly as seen. All right. Now we'll clear it. Go to 1 second exposures. And okay. And let's go to auto. Give us a full screen view. Okay. Kill the live stack. Clear first. Kill the live stack. All right. Now, no journey tonight is complete. I know I want to go to the Witch Head, and I will. But no journey is complete without going to this other location first. We're going to have to do this. We have to do this. Because this is one of the most beautiful nebulas that I think is in the sky. It's called the Rosette Nebula. It's like a rose by any other name. All right. So here we go. You'll see the telescope. It's going to be moving to a star. And which star is it going to pick? It's going to tell us. Alzir. Okay, it's taking Alzir. And where is Alzir? Alzir is up here. And we're going down here. Oh, then we can do the Christmas tree. Oh, boy. Yeah. Oh, yeah. We are definitely in for some real hot time tonight. Okay. This is what we're looking for. Okay, and once we get settled out, I'll move it in. All right. Okay, so let's move the telescope east. Thanks, Raymond. What you're seeing, Raymond, is the YouTube lag, the lag between the time we're actually saying something and the time you actually see it. There is actually a lag time, and that lag is, as you just discovered, approximately 38 seconds. I forgot to go into low latency mode where I wouldn't see that. My apologies. Okay, for those of you who haven't seen this object, it looks rather nondescript, doesn't it? But just you wait. It's going to just blow you away. This displays well. Let's just put it that way. Okay, this is the Rosette Nebula. The Rosette is a nebula that is just... It's stunning. It's a few thousand light years away. And it's also a stellar nursery, all right, where stars are born. This cluster that you see right here was born inside of it. You can see the faint object here. Let me make it a little more clear to you. This should tell you. Oh, what's that? There you go. That is the Rosette Nebula. Okay. So now let's head north a little bit. There, we're going to go to the Witch's Head, but I just was so close to the Hubble Variable Nebula, Christmas tree, cone, Rosette. I just have to do that circuit. I got to do it.
I don't blame you. I probably would
just
too.
Yeah. All right.
I stepped outside for a minute. Orion's
clear
already
out.
west of the meridian here,
Yeah.
and
So it's almost
Sirius
west of the
is
meridian.
Sirius is almost on the meridian here now. We're
Well, if you look
both
at
in
the
the Mountain
telescope,
Time Zone. Uh,
yeah,
I'm about half hour ahead of you, Sky Time, I think.
yeah. Thank you, Raymond. But you haven't even seen it yet, Raymond. Wait until you see it. Oh man, that's gonna really just knock your socks off. Okay. This is a 25-second exposure of the Rosette Nebula. And what you're going to see, I would have to say, there's so many things going on in this nebula that are teaching moments that it's just incredible. I'll point out a few of them. Daryl can point out a few of them too, I'm sure. There's many things that are happening inside this nebula that are worth talking about. So watch this. And oh, how about resume? Sorry. I built it up and then faked you out. I didn't mean to. Okay. Okay, watch this now. So this will be now the Rosette Nebula. Wow. Okay.
That's so pretty.
It is so pretty. Now, what I need to do, though, before we get into this, I'm going to kill the stack for a minute and go back to 1 second exposures, because I am going to make a concerted effort to just check my focus system, make sure it's working right. All right, and we'll zoom in now to 200. Now we'll do 150. Okay, as you can see, the learning system that I had enabled for it wasn't quite right. All right, so 23.58. See, that's closer. Okay, so let me see now. Actually, that's pretty good. That's pretty good. The stars, little stars are tiny. That's what they're supposed to be. All right. Now let's go back out to auto and do the stack again. Now look how sharp the stars are. You ready for this? It's going to be beautiful. I'm even going to make up a word. It's going to be beautifuler. And we'll do 30 seconds now because I'm so confident in this. All right, here we go. And this is the earlier live stack of it, and it's not quite focused. So it's going to be even better than that. Yeah. It's going to be better than that. This will be better than that. I'm telling you. Just watch. Watch it to be better. All right, here we go. Stack reset. I mean, I'm only doing like 10 things at once, right? So what's the big deal? Ah, look at that. Now, that's stunning. Now, that is a beautiful nebula.
It is.
Look at that. That's a 30-second shot, guys. 30 seconds. JSCO, more beautifuler. That's exactly right.
You know me
Yes.
and lines of stars. The one
Yeah,
that really
you
jumps
got
out
some?
at me here is up at about 10 o'clock from the center of the nebula. There's that curve
okay.
of like 2 or 3 rows of stars all together right there.
Here?
Right there.
Yeah.
Up a little bit. Up a little bit. To the left a little bit. That right there.
Okay, right there. Okay. Yeah, that's very interesting.
And then there were a bunch of
Okay,
other
so-
lines of stars all over the field.
Wow.
couple on the left side.
Mm-hmm. Let's
The
see about adding
fine
some more
strings of
background
dark
data.
nebulosity there. Oh, inside the nebula itself, there at 12 o'clock and 3 o'clock, and
Yep. Yep.
everything in between. That's really something.
It is. This actually might be the best I've ever seen it. Let me go to 200%, even though I've only got a couple frames stacked. Oh my. Yeah, this is really pretty. This is really pretty. That green line, by the way, that's actually a artifact of the camera. I removed those in processing. So, no big deal.
He ran over a Prius, OG. And what was the other car? I think the other car was a Porsche. He was
What are you
driving a
talking
big
about?
old. Arnold drove over someone yesterday in his SUV, as OG Skywatch says.
It was not my fault. He ran out in front of me.
Yeah, he ran
I did
over
not
a
see
Prius
him.
and he hit a
Ran over
Porsche
a
too,
Prius.
I believe.
Wow. He was really in a hurry. What did he do that for?
I forget. I think today was his birthday, or yesterday was.
Really? Uh-oh. What a birthday present. Happy birthday to me. Crash.
71 years old.
Yeah. Okay, guys, check this out. This is a really interesting location, because you see these strings of dark knots. Okay, they're like distinctive. There's a distinctive knot. There's a distinctive knot. There. These might be areas that are condensing to possibly form new stars. You know, because it's out of this dark dust where new stars will eventually be formed. And then we have these really odd things like little tiny separate little black areas, little black dots like this and this. These are areas, you got it, these are areas known as Bach globules. When I was getting my degree in astronomy, I mentioned this before, I actually had the opportunity to be taught by Bart Bach, the man who found these. And he was an interesting guy. You could tell he was an astronomer, you know, shirt not tucked in, never wore a suit, polyester shirts. It was really kind of oddball, you know, but really good guy. And he had discovered these globules were probably the source of future planets and stars, and he was absolutely right. Now, if we zoom in on this one little location here, this one little location, check this stalk out right here. There's a stalk with like a knob on the end of it. But it's not the only one. There's another one here. Okay, another one over here. And all throughout this nebula, you'll see these stalks, and they're kind of like radial, sticking out on a radius out from the center. And that shows you that these hot stars in the middle that have carved out this area in the middle here, right? These hot stars in the center are also evaporating some of the material out into the outer extremities, and that makes these stalks over here. So this is a very dense area right here, and so the starlight hits it, and it pushes away and clears all the dust around it. Okay, so like the area around this here is being cleared by the star's strength and power, but then up here, this is a dense area. And so what's behind it in the lee side, all the way down the stalk, is protected by the density of this material here. So that's why you get a stalk. Now, eventually, it could be through turbulence and other movements that all that gets worn away until it just leaves a little tiny blob. And maybe that is partly to surmise where the Bach globules come from, these dark globs. But more than likely, these are just areas that are left alone and orphaned like these guys right here are Bach globules. There's many of them in this nebula. And if you look carefully, they almost look like tadpoles. Okay, you got this here, and it has like a little tail on it. This might be something called a proplyd. All right, a proplyd, P-R-O-P-L-Y-D. A proplyd, an area where you have this concentration of material and the stuff behind it is being evaporated, but this stuff is gravitationally condensing possibly. And that might be what we're seeing here. Same with this one.
Yeah,
Notice it also looks like a tadpole.
yes. If you look at the two big ones there, there's a little skinny one right between them, and it looks like it's getting strung apart.
This one?
Yes.
Okay.
See, it's faint, and it looks almost like it's evaporating.
Yeah, it may very well be. And, and like I said, none of this is gospel truth. We don't know that for sure, but we do know that these proplyds exist. We know that they actually do have a place in the process of star formation and solar system formation. But look at that now. And this is worth the full screen, I think. Bada boom. Yes, that's just beautiful.
That's very nice. So much
all in like a
going on
30-second shot. There is so much going on. Yeah, you know what? I'm a friend of Avi Loeb's actually, and we did a couple of shows together. We did an ABC special together, and Avi is gonna talk to me about the Galileo project as well, because I would actually like to consider having him put one of his scopes, one of the systems, out in our building. Actually, we'll build a separate building just for him, wherever we have to. But I think that it might be kind of cool to do that. But I'll be talking to Avi again soon. He's a good guy. And not afraid to go out on a limb. What'd you say?
I was about to say, could you give a simple explanation of the Galileo project?
It's the Galileo project is meant to hunt for extraterrestrial life by using a bunch of telescopes set up to look for certain technology signatures in the light coming from distant stars, and maybe our Sky Tour live stream spot might be a good spot for him. I would like to see that. I'd like to see that happen.
Cool.
In fact, I'll offer it up to him. I'll write him. I wrote him a message, a couple of weeks ago or a couple of months ago. So I'll send him another one. See what he wants to say about it. I mean, they haven't gotten to the point yet where they've picked sites. They're still developing technology. But Avi Loeb says he wants to come on the radio show, so I can maybe talk to him before the radio show. But I'm going to have Doug Trumbull on, too.
Mean?
Yeah, Sky Tour Radio, yep.
That'd
He'll be on
cool.
with us. And Doug Trumbull said he wants to go on, too.
Super.
Doug Trumbull, for those who don't know, Doug Trumbull is a Academy Award winner, actually a good friend of mine. And Doug met me when I did a show on NPR, and I was on an NPR station and talking about X-Files of Connecticut at that time. And the host said, I got to get you on with Douglas Trumbull next time. I was like, what? Douglas Trumbull? I mean, I modeled my FX business after his work because I own a visual effects business. And he, said, oh, yeah, he's a big UFO hunter like you. I'm like, what? And so I got home and I wrote Douglas Trumbull an email. Never expected to hear from him. Well, a half hour later, I get a 2-page email from him. Wow, well, this, the blah, 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 blah. You got to come up. I got to meet you because we're working on something that could use your talent right now. I was like, really? Next thing you know, I'm working on a Burger King commercial with 30 other people. And I was creating visual effects to do in camera and stuff. Really cool stuff. And I didn't even think Doug noticed me. I really didn't. But in fact, he not only noticed me, he was watching carefully, and at the end of it, he told me privately, he goes, you know what, Julia, his wife is a wonderful lady, Julia and I would like to continue with you on other things. Like, wow. And they brought me on to do other things, and since then we've done a movie about Nikola Tesla up at Niagara Falls. We've done other commercials. We did the Apple iPod Pro commercial, iPad Pro commercial there, and we got Alabama Shakes to do the music for it, and really cool stuff. Actually, you can watch that on YouTube. The commercial. It's called Great Big Universe, and it's on YouTube. And it's the iPad Pro. Forget the size, which one it was. I think it's all of them. But anyway, it's Great Big Universe, and everything you see in there, except at the end where they pull out and you see the screen, everything you see in there was an effect we created right in the camera. So what you see on the screen is what we saw in our special effects tanks or in our other, our other stuff. Because obviously, Doug was a big proponent of trying to get it, and still is a big proponent of trying to get the shot in the camera without having to employ very expensive computer graphics. It doesn't make him like an old kind of guy who just wants to use the old technology. That guy knows more about new technology than you'll ever forget. I can tell you that. Okay, so it's pretty cool.
I've known about Douglas Trumbull for over 50 years.
Yeah.
I'll probably tell you how I learned about him if you think about it.
50 years, okay.
Over 50.
What happened over 50?
Well,
okay,
2001: Space Odyssey, of course.
Well, I was about to, yeah, but that was in 1968.
Yes.
So you said 50 years.
Over 50 years.
Over 50 years, okay. All right. So that's fair.
Well,
look at this picture.
32 and 20 is 58, 52.
Yeah. This is something else, man. Yeah. Doug has these really cool talks he does where he actually teaches you, he shows you how he did the different movies. And he does one for 2001. He does one for Close Encounters of the Third Kind, which of course he did with Spielberg. He has one for Blade Runner. And he has one for Andromeda Strain, which he did. He has one for Brainstorm, which he did. He has one for all these movies. He's a big documentarian. So it's really cool. And, he's got this little magic room that's climate controlled in his office building with all this movie memorabilia in it. And it's just like a little museum. It's so cool.
I was so taken by 2001 when it came out. I read the novelization by Arthur C. Clarke before I ever saw the movie, so I knew what was happening. But B, because I was such a fan of the movie, I acquired the book The Making of 2001, which was a great big fat paperback, at least the copy I had was.
It is a beautiful book.
It was Douglas Trumbull this, Douglas Trumbull that.
Yeah.
The book, revolved around him very much.
Yeah, because he designed a lot of the things you see in that movie, and that made his career.
Yes.
I'm astonished by this nebula, guys. I don't have any words. It's just so beautiful. It's just so beautiful. Yeah, fantasy, but I agree with that. But keep in mind that he also built a gigantic garbage mesa in his living room. So he wasn't all there to begin with, in a sense. Of course, Doug Trumbull didn't write that part of the story. So, this is beautiful.
I always had a problem with Close Encounters of the Third Kind.
Yeah. Okay, I'm saving this. We've got 32 images stacked. This is by far one of the best images we've ever taken of this object. So this will be up there for you guys to see. And we're going to save it exactly as seen. What do you have problems with?
Oh, just, I don't know. Was that a Spielberg movie?
Yes.
Okay, well that's why right there. I always feel like my chain is being pulled when I watch a Steven Spielberg movie. That he's jerking my chain, and I don't like that. Yeah, what can I say? I mean, it was enjoyable, but I can tell when it's a Spielberg movie. As far as his wife goes in the movie, Terry Garr played his wife, didn't she? And Melinda Dillon, the mother from A Christmas Story, she played the mother of the little boy.
Yes.
Who got
Barry.
carried off by the UFOs.
Yeah. That was Barry. That was his name in the movie.
Yeah. I always liked Melinda Dillon.
Yeah, but you don't like her when she's mad. Man, she gets pissed off at those aliens and never, they're never coming back. Okay. I guess while we're here, we're just a stone's throw away. So I think we should do this and get Hubble's variable nebula in if we can, don't you think?
Sure.
We'll try it. All right, so here we go. We're going to look at the Christmas tree cluster.
I need
Christmas
to step
tree
away
cluster
for
is...
just a moment. Be right back.
Okay, all right. The Christmas tree cluster is a beautiful cluster of stars. And if that's all it was, it would be boring. But it's not. Okay, we're slewing to Alzir again, centering it, and then we're going to move to the Christmas tree cluster from here. So it's auto-centering Alzir, and then it's going to take off and head down to the Christmas tree cluster. 1, 2, 3. There it goes. Okay. Now, what's interesting is you also see that it's got some nebulous detail around it, which is kind of interesting, right? And that's also cool. But we're going to go down just a little bit as well and over. Because I want to show you something else that's associated with this as well. When it finally responds, there we go. You hate it, but you love it. I want Starlink. Okay. Yeah, let's see here. There it is. Okay, all in one shot. This is what's cool about this shot. All right, and I'm going to show you right now. Okay, we've got this object here. We've got this object here, which will be clear in a minute. And we've got this object here, which will be clear in a minute as well. Welcome back, Daryl.
Thank you.
Yeah, I got them all in here. See, we got cluster, this, and that. So
I see that.
I'm now going to... Yep.
Hubble's variable nebula down at lower right. I see the Christmas tree. I see the cone, I think.
Yeah,
Cone's
you do.
just below the tip of the Christmas tree, isn't it?
It's right here.
Yes.
But you'll see. Everybody will see. Now, this is going to be pretty too, guys. You're going to look at this and go, oh my gosh, what the heck is that? This, by the way, is already on its way up to the server, so it will be there for you to see. So here we go. This is the Cone and Christmas Tree Nebula and Hubble's Variable Nebula. 3 very, very interesting objects in one. Notice the telescope is pointing almost straight up, so we should be afforded some very nice views. Wow.
Yep.
Wow. And there's Hubble's Variable Nebula down there. This is stunning. Turn up the music for this. The Christmas tree cluster is a beautiful cluster of stars, and it's also causing a reflection nebula, or what we call a scattering process that makes the nebula look blue. Down below here, this object is a cone nebula right here. This is the cluster with the reflection. The Cone Nebula is right here. Cone, C-O-N-E. And then way down here is another reflection nebula called Hubble's Variable Nebula. Called so because there's a dark cloud that this all sits within. And this is a nebula that changes in its brightness because there's a star that's inside the dark cloud. That star actually has like asteroids going around the sun. It has dark dust that's going around it, and it will cause different amounts of light to strike Hubble's Variable Nebula. All right, and thus the nebula changes brightness from time to time and looks different. We've seen it a variety of different ways just in what we do, right, Daryl? You remember?
Yes. The Hubble's Variable Nebula, you can see it change physically over the course of just a few days. We've followed it in winters past. That you know, we'll look at it and then go back and look at it again a week later, and it has changed quite a bit in appearance.
Yeah.
It's like shadows being cast on a wall or something, sort of. That you can see them move.
That's right. That's a good way to put it.
Over the course of short periods of time.
Yeah.
When you look at the Christmas tree there, that's a star cluster. The Christmas tree is hanging upside down. So the bright star is actually the base of the Christmas tree up top. And the bright star down toward the bottom of that pointed shape, just above the top of the cone there, that's actually the tip of the Christmas tree.
I thought this was like a feather duster on top of the Christmas tree.
There is so much cool stuff going on in Monteceros.
I know. And then over here, we have this beautiful cluster.
Yep.
Okay. So, and then we have this other dark nebula here. There's a dark nebula here. And all throughout here. And then this is dark nebula here. That's all throughout here, of which the cone is a part. It's a tongue sticking out over, over a bright nebula back here.
Isn't there one other object in the area there? I never can remember its name. Something Fox Nebula or the Foxfur Nebula, or is that somewhere else?
Oh, I don't remember. Why don't you look that up?
Okay.
Look that up and see.
Give me a moment.
Okay. Let's zoom in a little. Here we go. The Cone Nebula is somewhat hard to capture, but there it is, and it has two interesting little spires on it. You've got one, and it's going to come back a little bit here. Hey, what happened? I didn't do that. Not me. Let me just do this. Let me do this other way here.
I guess not. I must be thinking of something else. Deep sky objects in Monteceros. There's M50 and Open Cluster, Rosette Nebula,
Yep.
Christmas Tree Cluster.
Yep.
The Cone Nebula,
Cone.
Indice 2254, Hubble's Variable Nebula, and IC 447, a reflection nebula.
Okay. So you can see in this image here, this is the cone, all right, and there's two stars on top which are actually really close to each other, and there's just so much going on here. But it's an emission nebula parked right next to a dark nebula, but then you have this other little bump which is also got an emission going on. So it's really something else. And we'll back out again here. And then down here, Hubble's Variable Nebula is actually overexposed. You know? It's actually overexposed because we need to actually see. Let me see if I can actually drop that down. Let's do this. Let's see how much dynamic range we have here. Okay. See that? So there's stuff going on in here. We would need to take a shorter exposure of a nebula. And I shot this with a 20-inch refractor. And the images are pristine in a 20-inch refractor. I really enjoyed taking photographs of that with this, with that.
When
Okay,
we looked at Hubble's Variable Nebula before, and when we could see things happening in it over the course of time, that was with the it was either the 10-inch working at f8 or your other 10-inch f10, wasn't it?
I think it was a 10-inch working at f6.3.
Oh, you're right. Yeah, f6.3. Sorry.
It's all right. Yeah, so this is a really, really very complicated region, you know. And, you know, because of the internet connection, you can see sometimes there's that it takes time for it to catch up, and it looks blocky. That is not on the final images. In fact, the images are just absolutely not ever that bad at all. I actually deleted about 25 directories of stuff before I collimated, because none of those photos were worth keeping. They were all very bad. So what I did was I actually got rid of them and kept only the good ones. And we still have plenty of good ones. So this is beautiful.
It's interesting. Wow. Cone Nebula was discovered by our friend William Herschel, 1785. You know, a lot of people know the name of Charles Messier, but William Herschel discovered a lot more stuff than Messier ever did.
Yeah, and to be able to be able to move his telescope was just a feat of engineering. You know?
Didn't he pack
Herschel's
up,
telescope was...
I'm sorry.
Huh?
Go ahead.
No, go ahead.
He packed up a telescope and took it to the southern hemisphere, didn't he? Cape
Was
Town
he the one
or
that did that?
someplace, maybe?
Did he do that?
Him or his son? I forget. I know he did get down in the southern sky.
All right. Well, guys, that's going to be up on the server. And now we're going to head to something else nearby. Let's go look what we're going to see. Look how beautiful fine points those stars are. This is great. All right. And I think it's not complete unless we go to this guy too. We have to check this out too. As long as IC 2169. This is just a stunning region. So we're going to go check it out. And we're doing it in high precision. So we're going to go to the nearest bright star, use that as a signpost to guide us to the next one. It actually has improved the accuracy of the telescope by about, I'd say 50%, maybe 40%, 50%. All right. So it's Alzir one more time. Alzir, popular star tonight. Very popular star. So you guys having a good time? Oh, JSCO, the bubble at the tip of the cone. That's actually a rounded area that's being evaporated by the stars up there. So it's a perception of a bubble, but it's not really a bubble. But it's cool. Okay, I believe this is the object we're looking for right there. So I'm going to move our... Yeah, go ahead.
I see a faint fuzzy.
Yeah.
Yeah, you're moving to the right now.
Right here.
Yeah. A bright faint fuzzy about a fourth of the way over from the left side near center. And I see dark stuff running all over the place. All over the image. Yep. Looks like spiders.
And there is. Right there. Yeah. I gotta... Okay, first of all, it starts here and goes to here, right, and here, and all there. So I guess I could start here and make this the shot. This looks pretty cool because look at that. We got that up here too.
Oh, that little faint fuzzy looks almost like a comet.
Yeah, I know, huh? I promise it's not though. All right, so let's do this. Let's do a 30-second shot for this as well, and go into our live stack where we will clear the previous live stack. Boy, looks like internet is getting slowed down a little bit. All right. Okay. All right, and now let's jump out of this and see the full impact of this image.
This is something new.
Oh yeah.
Wow.
Yes. Yeah. Check it out.
I am.
Let me give us a little more. Okay. All right. So this is a beautiful area of reflection nebula, right? And let's, when the net stabilizes, we'll be able to see it better. Get the colors rendered properly. There, that's a little better. All right, so we have some red diffuse nebula here, this beautiful area, this black material here, this black material here. Again, it's just an area that doesn't quit, you know. Look at all this nebulous detail here. Look at it. Yeah. Oh, this is just a... It reminds me of Fuchsi, you know.
The upper left corner, you've got a big, pretty dense, dark area. And then much of the rest of the image, it's like I've seen on... there was one other one, I don't remember what it was. Like dark spider legs running all over the picture.
Yeah, like
big
this.
One running toward the upper right. Others all over the place. Yes.
One there. Some of those are actual, and some of those are imagined.
Yeah.
But I think most of them that we're talking about here are actual.
Yes.
Okay, we stacked 4 right now, and let's just center on this for a minute, because this is really the interesting part of this photo. That's just something else. Look at that. And this material comes down here. This material is involved with this as well.
Mm.
See this area right here? This is like a gap in the black material. Okay, the black dust, so you can actually see what's between, in between and beyond. This is all overlaying stuff that's laying over the stars. Just something else. Rascally Rabbit, how you doing, man? Good to see ya. Wow.
I see several faint fuzzies now. That one on the left side, can you go to Stellarium for a moment?
Sure. If it comes up, all right.
Okay, what would it be? What would that faint fuzzy be? Indices.
Well, it could be.
I can't read that one there.
2167.
Or what's that? 2245.
This is IC 2167. 2245. Yep. And then we have.
That's the big one.
Is this the one? IC 2169.
Some of that
Then we have
spider-like
this-
stuff shows up in the Stellarium image too. Interesting.
Yeah. Well, keep in mind now, if you notice what our field is, right?
Yeah.
This square represents the size of our field. So we've got this, okay, and it's on an angle, and we have it there, and there. There it is.
Okay, 2245 is that one I was thinking of. It's about halfway up and about a third or a fourth the way over from the left side.
Okay.
The three of them make a triangle above the big cloud.
Here. Yep. Okay. This is just a beautiful location I wanted to show everybody because it's just so cool.
Well, that's really cool.
Yeah. I thought you'd like it.
Oh, yeah.
Yeah. It was new. It's something new that I found that was sort of off the beaten path and not many people look at it.
Is this still in Monticeros?
Yeah, we're still here. Let me go back to Stellarium to just confirm.
That's really interesting. Yep. Yeah, there's the Rosette just to its
Yep.
lower right.
Yep.
Fascinating.
Yeah. Okay. Let's go over now. I mean, I could go down south here and head into other things, but we need to let those objects cross the southern meridian first to be highest in the sky. I don't know if they are. Let's find out. Yeah, not yet. Not yet. But let's go, before we can't, let's go and look at something that is pretty much almost the highest point. It's not quite yet, but it will be. Let's take a look at the Witch's Head Nebula. Right here. But we're going to actually go to this little star. Because that is going to be a better location. The Witch Head is pretty faint. So the telescope's going to go, and I'm going to pause this, save it. Alright, and then save exactly a scene. and get out of this. And then go back to 1 second for this. All right. There we go. And there's Rigel. Rigel is sometimes the brightest star in Orion, but Betelgeuse is technically the brightest star.
Yep.
Okay, let's see what this... Alright. Let's see if we got there. It doesn't appear that it's exactly where I want it to be. Okay, come on, Stellarium, come on up. Oh, this delay is killing me. Okay.
Seems pretty pokey tonight.
Yep. It's definitely pokey. Okay, Pokey. Hey, Gumby, give me a carrot. Alright. Let's get this going here. Alright, come on. Wow. Yeah, this is slow tonight. He gets. Alright. Well, supposedly we're here. So what I have to do is eventually I think it's there, but let me take a picture.
You know that I think I see your chin up in the upper left.
Right there?
Yes.
Okay, well let's find out if that's true. $30 seconds. And bring up the live stack. Clear this one. Look where the telescope's pointing. It's pointing toward the west.
Uh-huh.
All right.
Oh,
We should
like
see
I was
it.
saying, when I stepped outside at 10 o'clock, Orion was already well west of the meridian. And,
Yep. Yep.
yep, that's her chin right there.
You got it. All right, so let's get this open here.
Interesting. It's
So
not
you can
blue
see it.
tonight.
Well, not yet. We still have a ways to go.
Okay.
And I haven't color corrected it yet. So I will. If I can, you know. All right, here's color correction. I'm waiting and waiting and waiting. It's like, man. All right. I think if I was to take the dark level, move it just a little bit. Now let's see how that looks. A little too much. No, not that bad.
I don't mean to be a
That's a
bother. Uh, would it be possible to raise her chin up toward the top just a little bit?
well, yeah. I have to do this all over. I could do the whole stack over again,
Okay.
but I can.
Never, just curious to see if we can get a little bit more of her face on the upper part of her face.
Yeah, I actually, I'm thinking of a way to implement a rotator.
How so?
Well, the problem is the cables are anchored,
Yes.
you know? So I'd have to make a rotating ring on the tube of the telescope to rotate the camera and the cables around and maintain that so they don't twist. You know, but it only needs to rotate 90 degrees. You know, so it has to be an auto tensioning thing. All right, we can try this, Daryl, if you want. Let's we'll clear this and do it again. Let's go back to 1 second. But we're gonna need to get rid of this.
I don't know. Usually your
Right.
camera is at a pretty good position as a general thing. I've noticed just a couple of objects, like the witch's head here,
Yeah.
and M31 and Andromeda. If
Yeah.
it was maybe rotated about 10 or 15 degrees clockwise,
Yep. I agree.
I'd say try it right there.
Okay. I will do this. Okay, let's do 35 seconds. And off we go into the live stack. And clear. And we're going to see an object, again, this one you already saw, that is only visible because of the nearby star Rigel that's illuminating it. And it's scattering the bright, hot blue light, the high frequency light of Rigel. Rigel has, not all the frequencies in it. Okay, just less of some, more of others. Well, there we go. It's about the same. Didn't I just move it up?
I thought you did.
Doesn't look like it did, huh?
Let it go.
All right.
I can see her chin. I can see her lower lip, her upper lip, her nose. I guess I see her eye socket.
Not the eye socket?
Yeah.
Right there?
Maybe back a little or to the right. But,
Okay.
Uh,
I was never
big
good
bo-
at seeing those.
big bony nose. I see her mouth is open, her upper lip and lower lip, and her chin up at the upper left. It always looks like the
Okay.
Wicked Witch to me from Wizard of Oz.
Wizard of Oz? All right.
You don't see that?
No, I do. I'm working on just trying to get the color rendering.
I'll get you and your little dog too.
Oh no, Toto, we gotta go. This isn't Kansas anymore. Yeah. The Witchhead Nebula. I think we got more than enough objects here to keep Izabela busy, so I would say that this one will be our last object for tonight.
Okay. Yeah, I'm actually going to go to
Rascally
bed
Rabbit?
pretty soon.
Did you say minus 28 Celsius there? Oh, thanks, Rascally. I'm glad you like them. Remember, the address to this is also in the description of the stream. So we're going to go to about... the address to the server is also in the description of the stream.
Oh.
I put it in there now. Hey, Andy Morrow, how you doing, man? Haven't talked to you in a long time. Oh, you did the Witch's Head from, another source? Or did you do ours? I do not remember.
Weren't the blood worms
Rigel
from
7.
Rigel? Rigel
Rigel 7. That's right. Damn it, Jim! I'm a doctor, not a bricklayer. Remember the hoarder?
Oh, yeah.
Bones, you're a healer. Fix it. I'll see what I can do. Jim, I'm beginning to think I can cure a rainy day. I troweled this cement in there.
Yep.
Cement. What was a silicon-based creature? Which is, as we know, not the sharpest knife in the drawer if you're a silicon-based creature. Because your silicon bonds that you could create inside of your organism are hugely limited. And the ones that do get made don't want to be broken. Unlike with carbon, just above it in the periodic table, next row up in the same column, is the closest thing to silicon, right? And silicon is the closest thing to carbon. But the differences are night and day. Silicon bonds with oxygen, all right, and makes silicon dioxide, which we know as sand, all right? Well, silicon dioxide doesn't want to be broken apart. So if it makes the silicon dioxide, that's a very tenacious bond. And silicon tends to make crystalline bonds, which are very tough to disassociate. So any type of life form that would be created from silicon would actually be created in a crystal lattice, probably, of sorts, you know. So it's interesting that people say, oh, well, there could be silicon-based life. That's because they're just looking below carbon in a periodic table and saying, oh, it must be because it's so close. It's night and day. They're nowhere near each other in capability. Carbon bonds with more things than any other element in the whole periodic table. Carbon has more flexibility. It can make and break bonds so easily with carbon. And those that it wants to be tenacious about, it can be tenacious about. But silicon's tenacious for all of its bonds. It doesn't like to break bonds. So,
on the other hand, remember Star Trek Next Generation, they had the crystalline entity.
Yeah, I remember.
Maybe somebody had looked at their chemistry book before they came up with that one.
Yeah, it would have been nice if they had. Mr. LaForge, I don't think a silicon creature can survive. Captain, I think maybe it can. I mean, I thought LaForge was like Corporal LeBeau in Hogan's Heroes to Hogan. You know, it's Geordi to Jean-Luc Picard. Geordi was Captain Picard's LeBeau. Okay, well, we've got 12 stacked here. That's pretty good. Let's zoom in and see if we can see any problematic areas.
Well, Facebook actually let me in to see Izabela's picture.
Well, that's good.
Won't let me go any farther, but let me see her picture.
Well, you should go in. You should get a Facebook account just so you can lurk. You don't have to put anything of yours up there. Just that way you can at least just see other people's stuff. You know, that's the only reason to get one. You don't have to get anything that tracks you, or you can actually make an email you'll never use. You know, with Yahoo Mail or something like that, or make a whole new Hotmail email that you just never use. They can't get you with. They can't track you down with those things. This is beautiful. All right, we're gonna pause this now. Save it. And then we'll save it exactly as seen. All right. And clear it. Come out of this. This was one good night, I'll tell you that.
Mm-hmm.
We actually did a really, really good job tonight. And that satellite. Good thing I told the picture to stop, huh? Because that guy would be going right through our view.
Mm.
Mercury based instead of water. Oh, mercury, yeah. The farther down you go in the table, by the way, down vertically in the table, the less prevalent those are, the less of them you'll find. So mercury would be kind of tough. Fantasy says, okay, how about carbon-based but mercury-based instead of water? Yeah, mercury is dangerous to our form of life. But, you know, and you might say, well, anything's possible, but, you know, nah, not really. Not everything is possible.
Well, I think back to
Isn't this...
when I was a kid, some of the stupid things I
Yeah,
did.
yeah,
We'd go fishing, and
yeah.
we had lead sinkers, weights for our fishing poles,
Oh,
fishing
yeah.
lines.
I,
I'd
I had
set them
those.
with my teeth.
Oh,
And
so would I.
I remember once in high school, I wore gold rimmed wire rimmed glasses, and I somehow managed to get a drop of mercury on my glasses.
Okay.
And I thought, oh, heck, that it looked bad among other things. It turned the gold white, and I started rubbing on it and rubbing on it and rubbing on it, and before you knew it, I turned the entire glasses frames white, silver instead of gold. And hey, I just put the glasses on and kept on wearing them.
That's cool. That's
I'm
cool.
perfectly normal.
Yep. Yeah, I know I told you that was going to be the last one, but now I'm doing the Cosmic Bat Nebula, which I've never seen before, so I figured we'll check it out. Andy says, play with asbestos. I did. I had a piece of asbestos that came in a rock collection. And it was actually pretty interesting.
My first grade classroom, I sat in the back row, and we had steam radiators for heat
Oh, I remember those.
in the school, and all the
Yeah.
piping was clad in asbestos. And
Yeah.
all the kids in the back row, we'd sit there and we would pick at that asbestos and blow it at each other.
You troublemaker. Okay, we'll do a 30-second shot on this and see what we're going to get. I've never seen this before, so we're going to find out what it is.
What's it called again?
The Cosmic Bat.
Huh.
Actual name is NGC 1788. The Fox Face Nebula that you were talking about. I might have missed it. Let's find out here. No, there it is. Wow. That's new. That's cool. That's neat. Donald Kunzer. Squeak. I actually have a vacuum tube behind me up on the shelf here in the office that's filled with mercury. It's got a gigantic wad of mercury in it. It'd fill the palm of your hand. Because mercury was used in the vacuum tubes to keep, I forget what, corrosion or some buildup of some contaminant. It would keep that contaminant at bay. Not sure what it was.
Oh, I mentioned in chat, I don't know if I've ever mentioned this here. I used to work in a mine underground here in Colorado, up in the high country. Molybdenum mine. It was the largest underground mine in North America. I was a mechanic there. We worked on mining equipment, and there were machines called slushers. And what slushers did was they had two big cable drums on them, and they pulled cables back and forth. The cables were attached to either end of a great big, sort of like a bulldozer blade, that they used to rake mine ore forward, that it would spill through a draw hole and fall down into freight cars down below us. And that was how they hauled the ore out of the mine. And the brake shoes on these big cable drums were made out of pure asbestos, great big rectangular or square blocks of this stuff, about an inch or so thick.
Wow.
Maybe about 6 by 8 blocks. And sometimes the drums where the brakes rode, sometimes they'd crack, and every time that thing spun, it was just like a planer in a carpenter's shop. It would just shave that asbestos off and would puff up big clouds, and well, it make you wonder sometimes. That's quite a nebula.
Well, yeah. Asbestos is good for you. It just needs some mustard, according to David Schmidt. Hello, David. How are you?
Hello, David.
I used to actually, I would take the asbestos rock, and I would just start rubbing it, and these little fibers would come off. And I would twirl them up in my fingers and throw them down. I mean, asbestos in a rock collection that you buy. And guess what else was in the rock collection? Uranium. A radioactive element was in this rock collection. I still have that. I still have the uranium.
Our folks gave us a chemistry set for Christmas one year. I don't remember what all was in it, but there's some pretty funky stuff that was in there. This is way back in the
I made gunpowder.
Yep, early 60s.
It was a metal case, and I had, on one occasion, I almost blew my room up. Okay, because I made gunpowder, and thought, well, that can't be too powerful, because it was only about as much as like a cap in a like a bottle cap, like a Coca-Cola cap. But I filled it right to the top, a little mound. And I thought, no, I got to put that inside something like a containment. Because I lit one, it just went psh, did all kinds of sparks. I said, no, let's contain that. So I was thinking in my head, I'll make a jet engine out of this stuff. So I put it in a container, but I guess it was too fast of a reaction for the container. And it was like a cardboard thick tube. Kind of like the old Estes model rocket engines, but it was for something else. And I plugged one end with not clay, but like plastic wood or something, and I at the other end I stuck a wick in there, and I basically made an M80, but it was more like an M100. And so I lit it in my room. Nice wood floor. Regular house, 8-foot ceiling. And I swear I couldn't hear after when that thing blew up. I couldn't hear for like probably a half hour. And I just heard, eee! And I was like, oh, my head. And no one was home, because that's when he did all the bad things, when no one was home.
Oh, yeah.
So I ended up doing that. I had a toy fire truck too, a snorkel that I could spray water with by hooking up to the hose, but it wasn't realistic enough because I didn't have a real fire to put out. So I lit the ground on fire near the truck. Went to put it out, and the wind picked up, and it caught on to more. Next thing I know, my whole backyard's on fire, and it's heading for the house. Oh, so I took the hose off and started spraying the hose, and that wasn't enough. But it went out eventually. And when my father came home, he was going to go lounge in the pool in the backyard, which is now scorched with, black marks where the fire licked at it for an hour before I could stomp it down. And I told, no, don't go in the backyard tonight, Dad. Let's just play in the house. Don't go out back. I want to go out to the pool, so I'm going to go out now. He went outside, and I heard weird sounds coming out of that guy. My father made weird sounds which I'd never heard before, and he came in the house looking for me, and he growls, "What did you do?" I don't know, Dad. Why? What's the matter? Your fire truck's all burned up in the backyard. What did you do? Oh, yeah. I made a realistic fire scene, and it got out of hand. And my mother saw it, and of course, she was always so dramatic. Not good.
Your gunpowder experience was discovering the difference between deflagration and detonation.
Yeah.
We did stuff like that. I remember you mentioned Estes model rocket engines.
Yeah.
We were into those, and at one point we powdered up a couple of the contents of a couple of them, and put them on our plastic green toy soldiers and the Jeeps and stuff, and set them off, and did that in the garage. Made a hell of a mess.
Yeah. I did something like that where I was burning sulfur in a test tube in the house, of course, and of course fill the whole house with a stink. Okay, and the weird thing is, when sulfur combusts and actually burns, it's blue. It's bright blue, and it's very hot, and it burns through a lot of things. It's a low temperature, low melt, but it's a pretty interesting element. Well, anyway, I was putting a lot in a test tube, and I just kept packing it and packing it and packing it. It's on a Bunsen burner that, of course, I had. And I'm doing this on my table, my experiment table, which had holes burned in it with acid and stuff that I'd been messing with. And the next thing I knew, I could smell something odd coming out of the test tube. So I did what you normally do when you want to figure that out. You light a match and put it over the opening of the test tube, see what you get. It was hydrogen. And the test tube exploded and blew up through the tube. The easiest way out was through the tube. And it went straight up, and this blob of what I could swear was alive just stuck to the ceiling, you know? And it just made a splat on the ceiling, and then it started to come down, like bleh, like in the Three Stooges where the cake sticks to the ceiling and then it starts to come down.
Yeah.
Well, just imagine more gooey and drippy. It dripped onto the table, going psh, 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 as it's hitting the table. And, of course, I'm standing up thinking, going, wow, that's so cool. Not even thinking that I'm literally in the process of getting my rear end beat by my parents when they find out what I just did to the house. So they saw it. Of course, I knew I got. They couldn't ground me because I had already been grounded, and that's what I did when I was grounded. But they did take away the chemistry set for a period of time. They made me paint the ceiling over, and it'd be okay for a couple days. But then, whatever was in it, it just came right back through, and it came back through black as ever, and just could not cover it over. So what my dad had to do was to cut the hole in the ceiling and make a square patch and stick it in and make a whole new section of the ceiling. And I said to him, "Can I have that old square?" "No!" "You can't." "Okay." So yeah. And then, most people know I made hydrogen balloons that I would blow up in the empty lot next to my house. And I made those with Drano, metal shavings, and water. I discovered through reading books this is gorgeous. Look at this beautiful brown trail behind it here. I discovered that you could take sodium hydroxide, which was Drano, as it turned out. I searched all over the house to find sodium anything, and I saw the sodium hydroxide, which was exactly what I needed based on what I saw in the library. And so I figured out the chemical formula, NaOH, I believe, for sodium hydroxide. And I wanted that H. I wanted the hydrogen. So I knew that I had to have a catalyst of some kind. So I put metal in water, and I poured the whole Drano bottle into there. I asked my mom, "Ma, do you have any Drano?" "Yeah, under the sink." "Why?" I go, "I just need it for a little experiment." "Well, don't use it all up." Well, I did. All of it. Okay. And I poured it in this old glass jug that was used for like the water coolers in the old days. And it was sort of like an antique. Well, I thought it was a great mixing bowl, so I actually filled it with that stuff. Water, shoved in metal shavings, Drano, swirled it around, and let it sit for 5 hours. That's when the reaction would begin, after 5 hours. And after 5 hours, it started boiling. And I would actually put a stopper on the top and 2 spigots coming off, one to take off the moisture into a moisture trap, and the other to go up to a moisture trap and then onto an actual balloon that I was filling with this hydrogen that was being driven off. And I knew it was hydrogen because I lit it on fire, and it went boom! And I was like, yes! I'm on my way. So I ended up making hydrogen balloons for that particular summer, and they were very successful, I should say. And so I ended up every time I set off a hydrogen balloon, it would rattle windows in the neighborhood, and people would call the police. "Something just exploded." "Okay, we're coming to check it out." And so as soon as a balloon would explode, I'd quickly go gather up the remains and run in my backyard. And then the police would go by very slowly, "What's going on?" And And I went back in the house and schemed another one. You said the Estes model rockets that you played with those. I actually took them and I made one mega rocket out of it. Okay, I said, well, that can't be hard to make, you know. So I made a mega rocket and said, I'm going to make the biggest skyrocket anyone's ever made. So I put a big stick on a gigantic cylinder that I had, and I stuffed like 5 or 6 D engines, worth of propellant into this thing, and then, locked it off at the bottom, drilled a hole in it with a hand drill, and then inserted a wick. All right. Well, I set it in the ground, and when I actually set it off, a little problem, big problem. The stick stayed in the ground, and the thing took off. It went, flew into the air, went up probably like 500 feet or more, crossed over trees, and landed on someone's roof where it was still going, and then rolled down into the gutter where it set all the leaves in the gutter on fire. So I ran over there, and I took their hose, and I started washing down the gutter. And the lady came out and said, Marky, what's wrong? Because I was a neighbor. I said, your gutter was on fire. I just grabbed your hose and put it out. Oh, thank you. You saved our house. Blah, blah, blah. I don't know what happened, Mrs. Gomez. So that's kind of what life in the neighborhood was like.
Yeah.
And that's just one of many crazy things we did.
Oh, yeah. I said in chat, my twin brother and I, we used to, double the trouble, double the fun. We did some really bad things.
Yeah. Well, I never hurt anybody, I never would do that. And I'm not saying that's what you did. I'm just saying I would never, ever want to hurt anybody. I was the kid that was always picked on. So I could never hurt anybody. I was always the one that's running from anybody else.
Oh,
okay, this one's up there.
We never purposely tried to hurt anybody, but
sure,
stuff happens sometimes,
Yeah. We went fishing, and one kid was rather portly, and we were walking out on this island of grass mat that was suspended over this pond, and we had to be careful to walk on the roots, because if you went in between, you'd fall through, and then it was thick mud and basically a death sentence. So we ended up going out to fish on these things right to the very edge, and the whole, you could feel the whole thing moving. And this one kid, he actually fell in between roots, and he grabbed the root, and he was like to his chest, and we pulled him out, but he was extremely heavy, heavy, and when he came out, he was covered in mud. What he didn't know, what we didn't know, was that when we pulled him out, all of his clothes were left in the hole because of the suction from the mud. So he was all muddy, and we were just totally covered with mud. So we thought he just had dirty clothes on. He knew his shoes were lost, okay? But that was it. So we walked out of there laughing, haha, look what Richard did. And we're going home, and we're walking home from Hamlin's Pond in Plainville, Connecticut. And it started to rain. It was a big thunderstorm, typical summer thunderstorm. And as the rain hit, okay, we're all looking up, and we're letting the rain hit our face. And Richard is sitting there, and he's walking, with the rain hitting his face. And that's when he looks down and sees that the water is washing off the mud, and all that's left is his birthday suit. And he's like, oh no! And he starts running. This little heavy kid starts running home. Ding, 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 ding. We're laughing so hard, I think I couldn't breathe. But it was really kind of cool. Cruel, I mean. And that was the only time we didn't do that to him. We saved him, actually. He really would have been hurt. But it was kind of funny, to be honest. We never went back there again, by the way. That was the last time I ever did that.
Mm.
Yeah.
So what is this thing
All
we're
right.
looking at?
Well, this is the Fox Face Nebula. I had it up on the screen, which you can't see because you got the other screen. It's the Fox Face Nebula. It's the Emission Reflection Nebula. And it's going up now to the server. It's beautiful. It's got this gorgeous, beautiful cloud here.
It is.
Cosmic Bat, otherwise known as the Fox Face.
Oh, okay. What constellation is this in?
This, I believe, is this part of Orion? Let's find out. Oh, I can't tell. Well, actually, sure I can tell. If I just click on this star, that'll tell me what star it is.
Oh, okay. That's Cursor right below it.
Oh, that Cursor. Okay, so Cursor, that's Orion.
Cursor is actually Eridanus, the river,
Okay.
which runs right up. Rigel is just out of view to the bottom of the screen.
Yes.
You're really close to Orion.
Yeah, this is in Orion. We're in Orion at this point.
Okay.
Yep. Very cool. That's actually a very beautiful nebula.
It is.
And that's saved, and that's up on the site. Alrighty.
Okay.
Well,
I'm going.
so
go
that's
to
the one
bed,
extra.
Marc.
Yeah, and I'm gonna close down. So what I'm gonna do is, I want to thank you guys for coming out and enjoying this with us tonight. We'll have plenty of time moving forward into the next month or so, and we'll be able to see so many more objects. That's a promise. Okay, so we're going to clear this. We're going to get out of this. All right, Daryl. And Daryl, I got to say, there was no noises coming from your mic tonight. It was really good.
Good.
I didn't hear them anyway.
I don't think I did anything different, but that's good. I'll try to
There we
arrange
go.
my cable the same way next time.
All right.
Okay. Well, if you'll forgive me, I'm going to head out of here, okay?
No, sure. Go ahead, man. We're going to shut down. I'm shutting down now. Thank you
Okay.
guys for coming out. And I want to thank everybody who donated. That's wonderful. You just humbling me very much. Thank you so much. It just goes to pay for everything we need out there, you know. Ongoing services, monthly fees. All right, Daryl. Well, thanks, man.
Okay. Well, thank you. Thanks for having me on tonight. Good night, everybody.
All right.
Had a good time. Hope you did too. Take care, and
I think they
be
did.
seeing you soon.
Okay.
Good night.
Talk soon. All right, good night,
Bye-bye.
Daryl. Bye. Well, thank you guys. I hope that you guys had a good time. I know that I have. I'm going to shut down. You'll actually watch me do the shutdown process if you wish. But it's being... just so you know, we're scheduled for Starlink in February, and that's just a few days away. So I'm hoping that we'll have Starlink very soon. The problem with Starlink was that they didn't have... it's not that they didn't have the satellites up there. I have 99.1% coverage through the course of the day where I am at this location with the telescope. The trouble is that they couldn't make the satellite dishes fast enough. Thank you, Raymond. Holy cow. Wow. Thank you, brother. That's so kind. You know, they couldn't make the satellite dishes fast enough, so I didn't get to get on the list because they were only making 5,000 dishes a week, and they needed like 10 times that number. So you can imagine how successful this whole system is going to be. Okay, let's get rid of this. I don't know, Raymond. I just want it to be soon. Okay, we're going to park the telescope now. And there it goes. Okay, the telescope is slewing the position, and then it says turn the scope off. See, we can. So my observatory program is dutifully doing what it should be doing. I can disconnect the camera now and close this guy. Alright, I can disconnect the telescope. Oh, I don't like disconnecting. I like being connected. Alright, I like being able to see the skies. Let me close it. Alright, and now the last but not least. So here is our... Oops, hold on. So here is our telescope in the building. And the last thing we do is close the roof. Good night, telescope. I don't know what it is. You know, running the telescope, all the things that it does, that's all great. But somehow closing the roof from 2,500 miles away, that somehow it seems to be the big thing. I don't know. Kind of crazy. But it's done. And now our telescope is to bed for the night. Alright, so you see we open the observatory, turn on pure power, turn off pure power, closing the observatory. As long as those are symmetrically placed, then we know we're good. And we're done with that guy. Alright. Well, folks, I want to thank you for being so attentive and wonderful. I tried to pay a little more attention to the chat tonight. It was really nice to see some of your comments. Thank you. So I guess what we'll do is we'll probably do this on the next clear night, which is probably going to be tomorrow. But we'll try to look at some different things tomorrow. We'll look at some of the same things, but some different things as well. All right. So I look forward to seeing you guys again. I would hope that maybe you will join us for that next sky tour. But thanks, guys. I look forward to seeing you the next time. You guys have a good evening, and I will talk to you on the flip side. Good night, everybody.